Hello everyone, welcome to our course on data mesh. So first, we have to describe to you what is data mesh. So data mesh is a decentralized socio-technical approach to sharing, accessing and managing analytical data in complex and large-scale environments. So the first thing you need to notice is that we're not saying it's a pure technical architecture. It's something that takes into account the technology of the system and how we organize it, but it's also something that concerns people, their responsibilities, what you congratulate them for doing, what you tell them that their job is and what their aspirations should be. Now, data mesh, at its core, is founded on the idea of decentralizing and distributing data responsibility to the people maintaining the systems that produce it in the first place. So you could say that almost everything else about data mesh is a bet on making that possible, that if we give responsibility for originating data to the people who maintain the systems where the data comes from, that will lead to better outcome, to more high fidelity use cases, to being able to use the data in better, more valuable ways. And the other aspects of data mesh are really kind of principles and approaches and ideas that compensate for the fact that we've given our operational teams an extra responsibility.
Yes, the wonderful thing about those principles is that they're quite solid and well explained. And we've decided to build this course around there. So first of all, what we'll be starting with why is data mesh important and why are we talking about it? And then we'll go through the 4 principles. The first one being domain ownership, which means that the ownership of the data is transferred from centralized teams to domain teams. The second one is called data as a product, which means that data will be much more than just a data asset. It will be treated as a product. And the third principle is self-serve data platform, which means that all of the data teams will be supported by a robust data platform. And finally, we'll have federated computational governance, which means that there will be some governance rules helping the organization succeed in data. And then the final section that we'll cover is how to get started with all of it.
Absolutely. So why should you care about data mesh? So don't just take our word for it. There are various analysts of the industry that are telling us that data mesh is something important and something we should be paying attention to. So our principal analyst of Forrester said data mesh is not going away anytime soon. Maybe more interestingly, McKinsey and company have said that data mesh can help large organizations manage data successfully if it's understood that implementing one involves more than technology considerations. So we already mentioned that data mesh is socio-technical. So that warning from the McKinsey consultants, I think, is actually quite good, which is that if you want it to pay off, you have to understand that it's about implementing things at the human level, not just at the technology level.
Yes, but don't take like our word or the word of McKinsey people for it. There are actual companies who have been implementing data mesh for a few years already. Since data mesh was first introduced around 2019, and since then a number of companies have been trying to implement it. So some of the big ones have been, for example, PayPal, which has been doing quite a lot of platform work in trying to establish the data as a product principle. Zalando has also been for years already working on trying to figure out how to decentralize their analytics work. And they organically kind of arrived to the same principles as data mesh. And then finally, we have Roche and Globo, which are actually quite close to our hearts because these are the companies with which ThoughtWorks has actually worked together to implement some of these principles.
Absolutely. And in the modern industry of IT, you also have to take into account what the cloud providers are doing, right? Because if the cloud providers make something easy, then it's likely to be something you can adopt. And if they're not paying attention to something, then it's something that might be harder or going against the grain. So you can see here that the large cloud vendors are all people who've started talking about data mesh, have all started to help make their tools more amenable to implementing data meshes, and also started to talk about and give advice how you might use their clouds to implement data mesh. I think maybe there's some data engineering companies as well that could be on this list, right?
Yeah.
like I guess like Databricks and other companies like that. Yeah.
Hi folks, now we're starting the new oil section. And the goal of this section is to give you an overview of the economic importance of data. It's really been growing very quickly over the last few years. On the graph on the left, you can see the amount of data that the world has been producing every year. And as you can see, like in 2010, the world was producing about 2 zettabytes of data per year. And by 2025, it's projected to produce almost 200 zettabytes of data per year. And this has a huge impact on the way that we work with data. Because if the amount of data is growing almost exponentially, then how can we assume that the ways that with which we've been working with data, or the tools and methods that we've been using to work with data, can still give us the same results that we've been expecting until now?
Mm-hmm.
And this is where we can connect to data mesh, which in essence is a decentralized way of working with data, bringing the data closer to its consumer and doing it in a responsible way. On the graph on the right, you can see that the big tech companies have a huge impact on the world economy. Now, companies such as Apple or Google and Microsoft, they're about 29% of the S&P 500 index, which means that they have a big impact on our lives.
I guess part of the reason they're so valuable is their ability to manage and generate value from data at scale.
Yes. And that means that every organization, every company has to start treating data differently. It can no longer be something that we do on the side. Data has to be the core of every modern business organization.
One of the key trends this year in 2023 that has driven the interest in data to ever greater heights is the development of AI. So if you look at the graph on the left, you'll see that investment in AI has increased massively from 2013 to 2022. And if you look at the graph on the right, you'll see that this is only going to continue. The graph on the right represents a survey of attitudes of executives, and you can see that 63% plan on increasing their investment in AI in their businesses, while only 37% don't plan to do so in the next year. So AI value is diverse. It has applications in marketing, sales, product development, strategy, finance, and more. And AI only exists because there is data to power it. Without this data-driven revolution, you wouldn't have this interest in AI, and you wouldn't have the potential to create value from AI.
So, as Chris mentioned, there's been a lot of buzz about AI lately, and a lot of it is due to the release of ChatGPT in November of 2022. And one of the reports from McKinsey says that already about 1/3 of organizations use ChatGPT regularly in at least one function. And this will keep growing. And not just because of ChatGPT, because ChatGPT is just one chatbot. In order for organizations to truly succeed in this field, what they have to do is actually take LLMs and to introduce to them the local context within which they operate. And that local context is different for a marketing department of a big organization or a small travel agency trying to take advantage of generative AI. So this is what we mean by generative AI being the new frontier. We'll have to build a lot of new AI-powered applications that take advantage of the local context in order to create valuable insights for its users.
Yeah, so in order to supply those local context and local insights, for example, if you want a chatbot that understands your company's knowledge base, or you want something that can interact with your customers that understands the history of other problems your customers are going to have over time, you're going to have to manage that data to successfully fulfill the promise of Gen AI. Now, so far, Arne and I have been talking about the upsides. We've been talking about money, of lines going up, etc. We don't want to be uncritical cheerleaders of a data-driven and Gen AI future. We acknowledge that Gen AI risks are neglected. Investment in risk mitigation is stagnant, I think partly because companies, though they maybe mention that being responsible with data and AI is important to them, aren't really putting their money where their mouth is. But also we think it's because they don't really understand what they need to do it responsibly just yet. Gen AI regulation is lagging. To use the EU as an example, because that's where Arne and I live, the EU is still working on a comprehensive framework, and we anticipate that it'll be working on a comprehensive framework for a good deal of time into the future. And even once there is regulation, GDPR shows us that working out what the implications of something is, working out how to incorporate it into our systems, that's something that still takes years, maybe forever. And finally, we want to assert that Gen AI responsibility is shared, that everyone needs to ensure data-related efforts are safe and ethical. So if you're someone who works in technology, whether it's as a developer, whether it's a data scientist, data engineer, whether it's a product owner or someone who works in the business side of things, we think that to have a responsible AI and data future, you're going to have part of it. And that's where we think maybe data mesh does have a positive role to play. So we called this section the new oil, and you could say that oil, like data, is something that drives a whole bunch of economic growth that companies and countries are scrambling over, that can have noxious side effects as it's being consumed. But the big difference between oil and data is that oil has no context, no individuality. A barrel of Brent crude is the same as every other barrel of Brent crude, whereas an item of data could be about a different individual. It could have a different insight. It could represent a different occasion in the real world. So really, if we want to act on responsible data, what we need to do is we need to understand that context. We need to make sure that when people are consuming data, that they don't lose the origin story of that data. They understand the conditions under which it's made, so they can make it accurate, and so they can make responsible decisions about how best to use it. And that's where data mesh, that attempts to, by giving domain ownership of data to the people who produce it, that's where data mesh really shines, because it gives us a methodology for preserving the context in data. So I don't think it's fair to say that data mesh will by itself cause companies and organizations to start treating data responsibly, but we do think that it's an architecture that really enables people to start taking data more seriously and treating it more responsibly. Hello everyone, welcome to our video on evolving architectural paradigms. So what do we mean by an architectural paradigm? Well, in general, a paradigm can be thought of as having three parts. If we fulfill these conditions, so whatever counts as participating in the paradigm, we can obtain these benefits, so the payoff, so long as we don't mind these costs. So the promise of this paradigm only pays off when the conditions are satisfied, the benefits are valued, and the costs are acceptable. And we think this is kind of a good engineering attitude to think about how well something works in what context.
So our philosophy is to say that not all of the paradigms tend to work in all of the contexts. What we need to decide is whether this particular paradigm works in our context, whether it's good enough for our context. And what we want to say in practice is that data mesh may not work in all of the contexts, and we don't want to shame you into using data mesh all the time. What we want to say is that data mesh tends to work in certain environments that we'll try to describe here.
Absolutely. So to get to this point, we need to talk about a few other paradigms, because data mesh is the culmination of a history of different architectural paradigms that have been combined and have evolved over time. So the microservices promise, as we define it, is that if we break things into small pieces, we can change them independently so long as we don't mind the added integration complexity. Right? So if you used to have a monolith and you split it into many small services, it helps you with the problem of being able to change them without having to redeploy the whole thing. On the other hand, if you now have 15 microservices where you had one big system, you have to think about how they plug together, how do you have a service mesh? Do you do synchronous or asynchronous calls? You've got all these integration concerns that you didn't used to have. And that's how paradigms work. Microservices help with some things and they make other things harder, and that's okay.
The second promise we want to tackle is the domain-driven design promise. And it's actually very tightly connected to the microservice one, and it greatly enhances it. So what this promise promises is that if we align our architecture to our business domain, we're able to represent our business accurately, even if it changes, so long as we don't mind adapting the technology to the business domain. And what that means in practice is that we shouldn't have in our organizations like big teams of database engineers or front-end teams, as we used to have in the 90s. Nowadays, especially with the microservices architecture, it's much more useful to have a marketing domain, a sales domain. And within each of these domains, we'll have teams which have all of the capabilities embedded into it. So inside of the marketing domain, you might have a team that has a database engineer and a front-end developer.
Absolutely. So in the data world, the first paradigm that really had a lot of currency was the data warehouse paradigm. So the promise of having a data warehouse is that if we model our data upfront in a central schema, we can run analytical queries across our business so long as we don't mind the effort of aggregating and reconciling data. So basically you map data to a schema that you've agreed with everyone on the way in. And that's really convenient because that means if you've managed to accurately do that, then it's easy to run queries against this model and figure out things about your business. But the problem, the thing that is the downside of the data warehouse paradigm, is that effort of working out how to map things on the way in, how to cut them, how to maybe evolve the model that everything's being mapped to, is actually quite a lot of effort when your business is at a certain scale. And so let's talk about the next paradigm.
Yes, and well, before we go into that one, I would like the audience to try to remember what it's like working in a typical data warehouse or a typical analytics project. You spend all of this time modeling the data, building up the pipelines. You might spend like 6 months developing all of it. And then you release it, and all of a sudden your business understands that the business has changed. The questions that you were asking yourself 6 months ago might not actually be relevant anymore, or that you've actually come up with a lot of new questions. And your existing schema, all of your existing models are not able to provide you the answers that you need in order for your business to keep moving forward. So this is where the data lake promise comes in. And in this case, instead of modeling our data up front, what we do is that we collect all of the raw data into a central location, and then we allow our businesses or analytics people to run queries about anything that they would imagine. And this gives them the flexibility to ask all kinds of new questions whenever they pop into their heads. There is a downside, and the downside is that the distance between the producer and the consumer becomes bigger. What it means in practice is that if all of the raw data is in a central location, we might be missing ownership to that data. There might be conflicting versions of the same data. The concepts become all muddled up, and there is a danger of us ending up with a lot of spaghetti code.
Absolutely. So data lake rose to prominence with digital native businesses because there was suddenly a whole bunch more data. You might remember from a previous video about how over time the amount of data we produce is going up and up. The problem with the data lake promise is this thing that Arna mentioned, which is the distance between producer and consumer. So when data lakes were mostly used for reporting, where coping with this ambiguity or being able to follow up as to why the data didn't behave exactly as you originally thought it was can be done safely during business hours, that was okay. But we're going to move to a future where we're using this data in real time to serve customer needs. So that's where the data mesh promise comes in. Right? So the data mesh promise is that if we give responsibility for data to the people who produce it, so the people maintaining the systems that generate that data, we can rapidly incorporate new data sources and use cases so long as we don't mind distributing skills and investing in self-service infrastructure. So you can see quite directly from this promise that it's most relevant, that it's most valuable if rapidly incorporating new data sources and use cases is something you're interested in, right? So we think that a lot of businesses today, that is becoming increasingly valuable. If your business doesn't value that, then you might not find that the benefits of data mesh stack up for you. But the thing we do have to also discuss is the fact that we've added a new set of priorities to these people who are producing the data, right? They're already busy. They've already got many different things they have to do. They have to do this security update. They have to deploy this new feature. They have to do the new branding on the site. And we're asking them to do one more thing, which is care about data. So that's where the distributing skills and investing in self-service infrastructure comes in, because we have to make sure that for these teams it's feasible that they take responsibility for data.
Hello folks, welcome to this section called Analytics with SLOs. We'll start by exploring how business intelligence used to work, how it transitioned into customer intelligence, and finally product intelligence. So, how have things been working basically until now? And I think that this situation is quite familiar to a lot of people because, well, I work in these kind of projects even nowadays.
Yeah, I guess we'll be laying this out as a historical development, but of course history proceeds at different speeds in different places, and probably even things we might describe as old ways of doing things will be done in many places still.
Yes, so the so-called old way of doing things has to do with how data used to be used for periodic reports. So when something went wrong with your data pipelines during the weekend, it probably could wait until Monday, because people didn't really need real-time information in these reports. They didn't even need the information like within those reports probably even on Monday, unless they had a big like year-over-year meeting that was looking at all of the business metrics that particular Monday. So the data used to flow from operational systems all the way into the reports, and there was probably a centralized data team taking care of the pipelines and the reports as well. And most of the time the data, if it got stale or inaccurate, if the pipelines failed and for some reason there was no data, it didn't really affect business decisions, because your business stakeholders were looking at the reports, kind of, well, hopefully taking some decisions based on those reports, but then there was also like a product cycle that was quite separate.
Yeah, and they can kind of apply their own judgment, or if something is really implausibly bad, they can give you feedback. If something is wrong, you know exactly who you have to apologize and negotiate with.
Exactly. So if you had a metric that somehow jumped over 150%, you could exercise your judgment and not take any decisions based on that. And most of the time it didn't directly lose you any customers, but that's not always the case.
Absolutely. So to segue to a more recent development, customer intelligence. So customers in modern applications often expect data and reporting as part of their extended user experience, right? So if something goes on the weekend, when you have an application where the customers are not just interacting with a system, but interacting with reporting on the system, then that's something that affects customers, that might disappoint them, that might mislead them, that might enrage them without having to happen on the next week, right? So it's something that can happen immediately. Potential sources of problems are now a little bit greater, because not only is there the data pipeline from your operational system to the data repository to the report, there's also this feedback system where you have things going from your data repository back to production systems. So that's a whole other place where there could be errors, there could be misunderstandings, there could be failures. And stale or inaccurate data is visible to customers. It's no longer an internal thing. It's no longer a thing where you can apologize to your CTO and hope that she gives you credit for something else you did for her the other month. You have to actually worry that what you've done is immediately visible externally. So I don't know if you've got any good examples of products that use.
Yeah, so I rely quite a lot on my health data coming from my Apple Watch or my iPhone, and looking at metrics based on that. And also one use case which quite a lot of people are probably familiar with is coming from Spotify or Apple Music, where artists can actually look at how their songs, music videos are performing really quickly.
Yeah, and maybe another one would be, because those are kind of glamorous consumer-oriented ones, there are also more crucial but maybe less exciting business applications. For example, we've been involved with e-commerce clients where if you're someone who's selling your products on an e-commerce store, you want to understand what is selling, how much, maybe get insights into what kind of things are successful and not successful. So I think if you're a company who uses a software or a SaaS product at sufficient scale, you will expect these days that it comes with an amount of analytics, because that's really what you need to use it to its full potential. So customer intelligence is part of how data is used. Data is no longer off to one side and just leading away from production. It's leading back towards it.
And finally, we have product intelligence. And in this case, quite a lot of the expectations that you heard about customer intelligence also ring true here. So if something goes wrong during the weekend, like, you'll still interrupt the customers. But here the scale will probably be much bigger, because probably quite a lot of your product intelligence solutions will be powered by ML solutions. So, for example, you could have a pricing model that actually takes decisions in real time, and it affects how your application behaves, but also like what kind of an impact that application has on your customers. So you will have some like technical problems that we already touched upon. You could have, but you might also encounter like new kinds of problems, such as the real world and the model kind of drifting apart from each other. And understanding that these kind of problems have even occurred within your system can be quite challenging. And in that case, it's not even quite straightforward, like how do you actually start fixing these things. In the case of product intelligence, having things go wrong during the weekend can have a lot of unforeseen consequences.
So one way of visualizing this is to talk about the operational plane and the analytical plane. So if you look at the diagram on the left, you can see that in some sense, the analytical plane in a business intelligence context is downstream of production. Things that happen in the operational plane in production can affect it, but there's no way that you can break the operational plane regardless of what happens. There's a one-way flow. In this world, probably data warehouses and data lakes have been designed to thrive. Now, if you look at the middle part of this diagram, you can see a world where the operational plane and the analytical plane are still separate, but they are peers. So this is where we get into data-driven products, customer intelligence, or even when we talk about machine learning models and so on, serving customers. So there is a flow of data from the operational plane to the analytical plane. There's a flow back, and so the causal chain of things that can go wrong is kind of circular and endless. So in this world, this is much more the world where we think that data mesh solutions might have a part to play, because data mesh solutions focus so much more clearly on context being preserved between the operational plane and the analytical plane. Obviously, it's no free lunch and doesn't make engineering itself become easy, but it provides a mechanism for there to be a responsibility model to handle this two-way activity. You can't just hide the data team in a corner and have data flow towards them and have them take care of their business on their own. You have to have a model of responsibility that takes care of that mutual relationship between the data world and the production world. Now, finally, on the right, this is a bit speculative perhaps, but we predict that distinction even between the operational plane and the analytical plane might eventually go away. At the moment, it's sustained by there being distinctions between professional skill sets, between tools that are optimized for one case and not for another. But we are seeing some level of convergence. So analytical tool vendors are trying to support operational workloads. Operational tool vendors are trying to support analytical use cases. I guess all companies would like their tools to be used by as many paying customers as possible. And also, I think just fundamentally, the idea of there being products and experiences and systems that aren't data-driven is going to become more and more marginalized. We've had databases for a while now, and I think the further we go, the more this kind of insight-driven system is going to be the norm, and the idea of a non-data-driven system or an unintelligent system will be seen as kind of quaint. So in the end, we think probably the distinction between the two will be dissolved, but for the moment, it's a reality that there's two separate ones with separate tool sets, with separate teams, and data mesh really, I guess, acknowledges that distinction without trying to unnecessarily perpetuate it. So just before we get into our tour of different models about how data and data teams can be plugged into wider organizations, we thought we'd trot out the classic quote from the Spider-Man comics: with great power comes great responsibility. So to some extent, people working in data have been saying for years, if only we can have access to business outcomes, if only you'll listen to us, that what we can do with this data can really help us serve our customers better or understand our customers better. However, the curse of that is that as soon as data people succeed in getting the rest of the business to listen to them and employ their solutions as critical path solutions for serving customers, then you have to worry about production support. You have to worry about things not breaking. So with that great power of people using data to create business value comes that great responsibility of maintenance.
And this great responsibility will take many different forms depending on how your teams are embedded within your organization. So in the first case, when you're just throwing your data solutions over the wall, you will probably find that your data solutions will be black boxes. You won't really know what's going on in there, and you'll just be getting signals from the interfaces. And in case there are problems with your solutions during the weekend, you'll be completely dependent on the centralized team taking care of that solution. So you as a product team member will not really understand what's going on there, and you will not really have power to fix issues when they occur.
Yeah, you're just going to have to escalate, and if the data application is sufficiently important, that means there's going to have to be people or person from the data team who can be escalated to.
Yeah. So you'll be totally dependent on Jira tickets.
Exactly. And that's a world, like just anecdotally, that's a world that I think some data teams and data organizations are not quite ready for. I've seen this kind of this conflict a little bit before, because teams in the operational world, I'm not saying on-call support is something that's necessarily easy or done well everywhere, but it's become a standard expectation.
Yeah, people are used to it.
Yeah, exactly. It's not going to be a shock. So one of the ways that you can handle this problem, this reality that the data team is now responsible for real outcomes and making things continue to work, is to use an as-a-service model. So you create a logical separation between the customer's services and the services that provide data or intelligence in the background. So the data science team might run a model with an API that is called by the product teams. Now, the way observability works is via contract and SLAs. So it means that you know exactly what those APIs are supposed to be doing, and you check in an automated way that they are continuing to do that. And if the data model is down, well, you do need to still escalate to the data team. But if it's up and doing the correct thing and the production system is having problems, that points the responsibility to the production team only. So the product and the API team have well-defined spheres of support. Now, a caution I would say is, for this to work, you have to be able to define observability and responsibility sufficiently clearly that when something is going wrong under a pressure situation and you are not around, people still accept clearly that it's not your responsibility, your fault. So that can be done, but it still takes a little bit of discipline that teams might not be used to. So you have to be able to know, I don't need to wake up this person because the problem is definitely elsewhere.
Yeah, then the big difference between over the wall and as a service approach is probably that since in case of services you have SLAs, you might probably be notified of things happening, as opposed to like your customers shouting at you like the next day because things didn't really work the way they were expecting.
Yeah, so you know problems directly. You don't find out through complaint. Yeah, exactly.
And then finally, you have the model where your product team and your data people are embedded within one. And in this case, you don't have to just rely on the SLAs. You're actually part of the team crafting those SLAs. So you will know when like things go wrong, and you will be able to fix them as well. So essentially, this is what we're quite used to in the operational world, with people being on call and reacting to problems when they occur.
Yeah, effectively, we've reached that cross-functional nirvana in the same way as the product team can deal with something that's happening at a database level or a CSS level. They can also handle it when something is going wrong at a data level. Now, I think in terms of these three models, both as a service and enablement model, I think can work. One is a kind of a platform team approach. Another one is an integrated approach. Probably over the wall, maybe you can tell from the pejorative way we've described it. It's not that it can never work, but I think at scale, it's not a really reliable responsibility model, and you're likely to find that you need to migrate from an over-the-wall model to either as a service or enablement, depending on the context. Hello, everyone, and welcome to our video on domain-driven data. So from this point on in the course, we're going to be going through the four pillars or the four principles of data mesh, and the first one of those is domain ownership. So we're going to explain in a lot greater detail than we have so far about what actually constitutes data mesh and how you know whether you're being consistent with its principles or not. So domain ownership says that decentralized and distribution of responsibility to people who are closest to the data achieves an ecosystem creating and consuming data that can scale out as the number of sources of data, number of use cases, and diversity of access models for the data increases. So basically, the place where the data originates is where it's owned. There's no separation of those two concepts.
So what really makes me happy about this principle is that as a data engineer, I will not have to deal with centralized data teams anymore. Like, there will be no more bottlenecks. And this will mean in practice that we'll have clear ownership of data. We'll have better understanding because the data and the team owning it are quite close together, so they actually know what they're doing. And finally, it will be a lot easier to add changes to that data because the teams owning it are in control of it.
When you say happier, I think that also applies to the people who would be in those central teams, because it can be quite a disconcerting experience to be responsible for data without having the full context to help people understand how they should use it.
Yes, that's what I mean. I've been a part of a lot of teams where half of your work is basically project management, upstream teams, to understand what are you actually getting from them.
Right, so you can just get them, the consumers and the producers can just talk directly without having to go through you. Awesome. So the way we divide this ownership in data mesh is through something we call domains, but which relate very closely to bounded contexts, which is a concept in domain-driven design. So recall that we said in the domain-driven design promise earlier that if we align our architecture with the business domain, we can represent our business accurately, even as it changes, so long as we don't mind adapting the technology to the business domain. So these units of ownership are based not around tech stack, but around concepts that people in the business would be familiar with, whether or not they're data engineers or software developers or testers. So a bounded context represents a sphere where we expect the language and terminology we use to talk about a problem to be consistent with itself and a particular perspective on the business. So not necessarily a global perspective, but a particular understood and consciously decided perspective.
So this consistent language that Chris mentioned, we call it ubiquitous language. And this means that we use the same definitions and terms to talk about the same concepts. And we do that within a bounded context. So people working side by side, they're basically talking about the same things in the same language. And this means that within one bounded context or within domain, you will have less problems with confusion or making errors because people don't understand each other.
Absolutely. And how does this relate to organizational boundaries, you might ask? Like, are we being excessively idealistic in talking about domains? So domain-driven design talks about the alignment between domain concepts and technology division. But where do people come in? Well, people who work for the same boss and who eat lunch together and have the same incentives and maybe the same problems, the same stakeholders, often use the same words for things, and they have the same priorities too. So ideally, all three of these things, people, domain, and technology, would be aligned. That's the nirvana. That means that you can really have a good understanding of what's going on because the people talk about things. You can look into the technology and see the same concepts using the same words. And then if you talk to people outside the business, they could still make sense of what's going on. But where these things are not in sync, we advise defaulting to the people because ultimately data mesh is a responsibility model. And so responsibility is something that is organized along the boundaries of your organization.
Cool. And this idea of combining technology, processes, and people, this also ties directly into how Zhamak envisioned whole data mesh. So data mesh follows the themes of organizational units. So it means that the organization should be clearly defined into domains. And that's in contrast to how we used to do things earlier, where we had an organization kind of following the lines of the technology, such as we used to have a data warehouse team or like a pipeline team and so on. And now within data mesh, we will have teams within domains, and domains are clearly separated along like what are they supposed to accomplish.
Absolutely. So in order to make these somewhat abstract concepts less dry, Arne and I are going to talk about an example throughout the rest of this video series. So the example we have chosen is called nomadnexus.com. And this is a fictional but world-renowned online travel platform devoted to empowering travelers of all sorts. So Nomad Nexus has this value proposition where it wants to simplify your travel planning process and enrich your trips with curated content, insights, and tips.
So from this drawing here, you can see that Nomad Nexus has actually been around for a while. You can see that there is a huge monolith in the middle of several domains that has been operating for a while already. And that there are some like microservices that are kind of like connected to the monolith, but nothing is truly independent. The domains have overlap, so they're not like clearly defined, which means that at the intersections of these domains, you might actually have problems with the language, with how people are communicating, with how the systems are communicating. You can see that there are some systems within the experiences domain that are a little bit more separate, but that's because, well, this whole domain was actually acquired and used to be a different company. So there will be probably like some integration problems here as well. And when we come to data, we can see that there's a data warehouse on the bottom of the image, and everything is directly tied to it. So there is a very clear dependency between what's happening in the operational world and how things end up in the data warehouse. So making changes in any of these services, regardless of whether it's a monolith or a smaller microservice or one of the acquired systems, will have a direct impact on the central data warehouse team.
So Nomad Nexus is thinking about whether data mesh can solve some of the problems it has, and really it's that experience of the people working in that data warehouse that really has brought things to a head and made Nomad Nexus think about data mesh as an option. So what happens at the moment is that data teams write jobs to extract data from all the different production databases, right? So they don't use a kind of any kind of data product or interface concept, just people directly go and access these things. Application developers are supposed to file a ticket to notify this data team if it's backwards incompatible changes to the production schema, but often they don't because they're busy or they don't think of it or they don't understand the pain it will cause to not do it. And that means that the overworked data team has to scramble around to keep the data warehouse running, even while the business expands, there's new markets being brought online, there's new features. So really, it's stressing this team of people out. So in future, they're thinking about moving to a domain-oriented model, and they want the data team to be less executors of anything that happens to be data-related, and more to be advisors or enablers for data in the organization as a whole. And that really also suits the career aspirations and the growth paths of the people in that organization who don't want to just be fixing broken pipelines their whole careers.
Hello, folks. This is the next video called Responsibility Shift. So as you can imagine, in the previous video, the situation that we described is quite unmanageable at scale. And there are a number of problems with this. And in this section, we'll go through all of them, dig a bit deeper and see like how could we do things a little bit better. So first of all, what kind of problems do we get when we have one centralized big data team? We have overlapping domains and a lot of connected services feeding into a data warehouse, for example. So what we get is that the data team will spend a lot of time managing different stakeholder requirements. Because of all of the services feeding into the data warehouse, they will have to take into account all of the different wishes of all of the various stakeholders within the company. On the other side, all of the stakeholders will also be interested in what the data warehouse people are doing. So you will have a lot of people like coming to your door and asking for new analytics capabilities. And it will be up to your team to like try to manage all of these expectations and prioritize them. So that's one problem you might encounter. The next one will be just about making sure that the data pipelines that you have in place, that they don't break. And that if you do any modifications, you don't break anything else that might depend on a particular data pipeline. And that can be, quite a stressful situation to find yourself in. And that in itself will lead to your team probably having a higher cognitive load, because you will have to have a lot of data pipelines to take care of and a lot of stakeholders to manage. And keeping all of that information in your working memory will take quite a lot of effort. And imagine yourself being a new data engineer joining the team, like how much context you will have to suddenly understand. And imagine yourself from the managerial perspective of like one of your experienced data engineers leaving the team, like how much knowledge they will be taking away and like how the team might suffer because of that.
Absolutely, yeah. When you depend on that much embedded knowledge, you're in a situation where you really, really need to increase team capacity, but you also can't because of that necessary knowledge to onboard someone new.
And how much time it will actually take to onboard somebody new.
Absolutely, because I think sometimes when people hear cognitive load, they think it's somehow something fuzzy or optional to consider. But really, increased cognitive load is one of the key things that software teams need to deal with and need to mitigate. Because if you have lots of cognitive load, you have a slower delivery pace for the team, and you have a stressful environment, which affects the quality of work, also the quality of life of people working there. But really high cognitive load is a problem that organizational people, managers in technical organizations really need to think about. Because if you have this situation Arne described where you have a team that is downstream of the whole organization and therefore to some extent needs to understand everything about the whole organization to do their job, because anything about the whole organization could affect their job, then you really have the risk of team members burning out and deciding to leave the company.
So why do we face the situation where like anything that happens within the organization will have an impact on the analytics team? It tends to happen because the operational teams, they don't have enough skin in the game. They don't take responsibility usually for how their systems impact the data assets within an organization. And that means that it will be up to the centralized team to handle a lot of these changes and a lot of the consequences of these changes.
Yeah, and we're not trying to say that it's the operational teams being gratuitously irresponsible. It's that everyone, including their managers, including those teams, and maybe even including the data teams, think of data as a byproduct of the real work. The responsibility of people is to, in the operational teams, is to crank out new features, is to make sure that the monolith and all the other systems are up and uninterrupted on the weekends when customers are buying hotels and flights. The fact that those systems also generate interesting data that the organization might use to create value is kind of a side effect, and not something that they're thanked for, not something they're congratulated for, not something they're incentivized to do a good job on. And originally, early on in Nomad Nexus's journey, that kind of made sense to allow the product teams to not focus on data, partly because data expertise is expensive. The data tooling was diverse and difficult to use, and the templates or the quick starts or the developer experience to get going were not mature enough. So it was hard to ask those operational teams to really take that responsibility we want them to take. But that's something that really has hit a wall with Nomad Nexus, because the heroic efforts of people in the central data team are not really enough to keep going. They feel like they're sinking, they feel like they can't keep up, and there's more things going wrong, more things breaking, preventing them even from paying down the tech debt that they'd like to. So these last two things we said, which were reasons to start with a centralized data team, data tooling being diverse and data asset templates and quick starts not being mature enough, we'll actually address those as part of the data platform part of this course.
So how do we improve the situation? And well, the answer to this is in the title of this video. We shift left. And what we do is we encourage and we create the organization so that the operational teams could actually take responsibility for the data work that their systems produce. Essentially, we combine the operational folks with the data folks in one domain or even in one team. And that will mean that there will be different capabilities that the team is expected to have. And in the short term, it might mean that like some operational team might get some data engineers within it. And well, the data engineers will be creating the pipelines coming out of those operational teams or systems. But in the longer term, we're kind of hoping that like this understanding of data and like how do you model your operational data to take into account the analytical requirements will spread around the whole, among all of the software engineers. Kind of the same thing that happened with the DevOps movement and how nowadays software engineers are the ones like setting up their CI/CD pipelines and worrying like whether they're efficient enough and so on. We're hoping that the same thing will happen with the data skills, and that hopefully even some of the operational systems and frameworks themselves will be embedded with data creation capabilities. But that's even longer term.
Yeah, but you have to change what you're asking people to take responsibility for this to work. There's no way to adopt data mesh or even, I think, to address the problems that Nomad Nexus is experiencing at all just by changing the tooling or buying new tooling. Really, it's about what you're asking people to prioritize. And the way that Nomad Nexus is doing it really isn't sustainable for them. Hello, everyone, and welcome to our video on distributing the data department. So it's a piece of almost folk wisdom now that in the operational world, we understand that the way that we design technical systems and the way we design human systems have a deep relationship. So if you design your human teams to have certain sets of subdivisions and they have communication patterns that work in a certain way, over time you can expect the technical systems to start exhibiting those same divisions and those same communication patterns. And if you do this consciously, that can be a great aid in maintaining the integrity of your systems and maintaining the cognitive load of the people working within it. And if you don't do it deliberately, you can find your architecture warped or pulled out of shape by the fact that the people working in that architecture are organized in a different way than the technical coupling. So if we go to the data world that we're talking about, if we have a monolithic data warehouse, well, from a Conway's law point of view, it's consistent and makes sense to have a single team working within it. So that team has unlimited ability to communicate with itself and touch any part of the monolithic system. But if we want to move to a world where we've divided up that monolithic data warehouse in a more distributed way, we also need to think about how the responsibilities of the people involved are divided as well. Because if, just say, for example, we needed to have multiple teams working in a data context, and we didn't think of a principled way to divide the responsibility, probably over time, we'd find that our supposedly cohesive and monolithic system would start to display certain seams that reflect the usage patterns of the people editing it, right? So there'd be some tables or some subsets that would be touched a lot by some teams and not touched much by others. And our argument is that consciously dividing your teams and systems in a principled way is going to lead you to a better future than letting it accidentally develop. So how do we do this in a principled way?
Yeah. So now that we know that we would like to go on with small autonomous domain teams, and we know that we would like to shift the responsibility for data to the left, how do we do that? So the operational world has also been struggling with the same issues for a while now, and they've come with a bunch of different solutions, one of them being called team topologies. So what is it? It's a methodology that Matthew Skelton and Manuel Pais came up with and wrote a book about it. And in this book, they outline 4 different types of teams and the communication patterns between them. So these teams are stream-aligned teams, enabling teams, complicated subsystem teams, and platform teams. They all have different missions and different ways of understanding whether they've been successful, and also different ways of communicating between each other. So they can collaborate, or they can enable APIs among each other.
Makes sense. And in general, they're all designed to produce circumstances where the cognitive load on the people working in these teams is not excessive. So if we take the first, maybe most essential team type, which is a stream-aligned team, what do we mean by stream-aligned? Well, that stream that we're talking about is the value stream to the end customer. So a stream-aligned team is one that is in a position in the architecture and the organization to directly deliver services and values to the value to the end customer. So that a stream-aligned team owns a slice of the business domain end-to-end. In a data mesh context, this team also delivers data products that reflect that team's responsibilities. So the insights and the analytics that come from usage of those products they're delivering, those are the responsibility of the team to surface as well. So in order to make this happen in a stream-aligned team, it makes perfect sense for data and machine learning engineers to be part of that cross-functional team. And that, in fact, enables the whole you build it, you run it philosophy. So that team has the cross-section of skills they need to work on features, to understand the infrastructure to put it into production, to support it in the face of any issues, and to create data products that make the insights and analytics generated by that system usable by the rest of the organization.
The second type of team is called an enabling team. This team is tasked with supporting the stream-aligned teams in overcoming obstacles and providing missing capabilities. So enabling teams are actually quite different from stream-aligned teams from the perspective that they're not actually producing value to the customer, but they're enabling stream-aligned teams to be successful. And this happens through mostly collaboration. So an enabling team comes in, provides some capabilities to the team, and then once that's done, once the team knows how to do something, or they have enough data people to accomplish their goals, they move on to the next team.
Absolutely. So a stream-aligned team knows they've been successful when the customer is happy, and an enabling team knows it's been successful when its colleagues are happy and able to do their jobs without further support. Now, there is kind of almost an exception or a tricky team type in team topologies we should talk about as well, which is a complicated subsystem team. So sometimes there are just systems that are difficult to understand, that require a great depth of expertise or concentration or focus, and it's not reasonable to expect the team to be responsible for both this subsystem and for CSS or user experience in production. So these teams concentrate on very complex technical problems, and they contain significant technical expertise. So maybe they need PhDs in certain subjects or people who have spent a lot of time studying those particular problems. So for example, there might be a team responsible for a complex pricing algorithm that makes predictions on which the whole business relies, right? That's something that shouldn't be just done part-time by people while they're doing something else. We need people who have focus and expertise to do that well. Now, I think you could say that ideally, from a point of view of flow and software delivery, you wouldn't have many or any complex subsystem teams because they're often difficult to work with, difficult to develop, difficult to fit into your technical landscape. And the march of technology really over time obviates the need for some of these complicated subsystem teams. So, years ago when I was working in operational systems that used content management systems, we needed a complex subsystem team to manage all the complicated configuration or subtle elements of the content management system. Nowadays, you don't need that because they've improved. So we hope that over time, maybe some complex subsystem teams will remain necessary in the data world, in particular, maybe complex models, but others will become unnecessary as the ease of working with technology improves.
And the final team type is called the platform team. And these teams are responsible for creating tooling to support all the other teams. And the key thing here is that the tooling is supposed to be provided as a service. And this is really where the platform teams could hook into the principles of data mesh. One of the principles that we'll address later in the course is called self-serve platform. And the platform team is responsible for building their tooling as an API so that all the other teams would be autonomous and able to use the platform services.
Yeah, absolutely. So our stream-aligned team who have to expose data products, they can still continue to work on the features they need to work on because the data platform team has given them tooling that makes it easier for them to build those data products. So in general, let's summarize the role of data people in data mesh. One, we've acted to distribute the data department. So data people will fit into every type of team outlined in the team topologies methodology. So the exact one depends on what kind of cognitive load, what kind of expertise or responsibility are you trying to manage. But it won't work in the same way as it used to when we used to have a single centralized team managing a data warehouse. So you'd say that kind of two scenarios that we see play out with clients quite a lot. In the midterm, we still see teams that are stream-aligned teams, not directly working on data products, but maybe collections of affinity between stream-aligned teams are pooling together to have some people that expose the data products for that whole subsection of the business. So kind of a subdomain might have a group of people responsible for providing all their data products as an interface to the rest of the organization. Now, the data mesh dream isn't quite that. The data mesh dream is that every stream-aligned team directly manages its own data products, but we think that in the meantime, while those data platforms become more mature and while patterns for working with data mesh become more well established, it seems to work for organizations that, if not directly every team producing its own data products, we have little groupings of related teams that together produce data products. In the long term, however, we anticipate that data skills become much more of a normal part of the software engineer's toolkit, so that plan and model of stream-aligned teams directly exposing their data in all cases is going to be more and more likely to be followed.
Hello folks, welcome to the video called Why the Product Metaphor. We'll spend the next few videos on the second principle of data mesh called data as a product, and we'll start by defining the principle. Analytical data provided by the domains must be treated as a product, and the consumers of that data should be treated as customers, so that data users can easily discover, understand, and securely use high-quality data with a delightful experience.
The word customer is interesting there, right? So why did Zhamak decide to adopt this terminology of product and customer in data mesh? Well, one reason is a kind of provocation. So organizations have for a long time thought about data as a purely technical concern, something that just has to be shipped around, that has to be manipulated, but not something that interacts with people or delivers value. So Zhamak, in her book Data Mesh, decided to adopt a terminology that would maybe shape the way we think about data and influence our behavior towards different outcomes. So traditionally, we might talk about extraction. In Data Mesh, we talk about publication, serving, sharing, all relational terms that imply the existence of someone who's benefiting from the data. Instead of ingestion and loading, we talk about consumption and use. There's something that's actually happening to the data. There's a destination that makes sense. And finally, instead of data asset and data set, we talk about data product.
So why do we talk about data as a product? This problem has been plaguing not just data, but it's also been quite relevant in the operational world. And for example, in case of platforms and developer experience, we've actually been talking about product mindset for quite a while.
Mm-hmm.
And the beautiful thing about product mindset is that it brings together a few characteristics that actually make a technical product. So these are usable, valuable, and feasible. And together they give a framework to treat any technical product as a product that's actually valuable to customers.
Yeah, and one that will return investment to the people who funded it in the first place. So in the book, we can delve into exactly how Zhamak frames it. She says, over the last decade, high-performing organizations have embraced the idea of treating their internal operational technology like a product, similar to their external technology. They treat their internal developers as customers and their satisfaction as a sign of success. So in a sense, your colleagues are not second class anymore into data mesh. You actually have to think about what's going to help them achieve their goals, what's going to please them, what's going to delight them.
So speaking of how customers are looking at data and what kind of language are we supposed to use when we talk about data as a product. So sometimes we see that people are confusing data product and data use case. And we've tried to outline the differences between them in this table. So when you're dealing with a data product, then you have direct access to the data. While when you're dealing with a data use case, it's usually incorporated into something else. So a data use case could be a pricing algorithm or a reporting dashboard. When you're working with a data product, you're probably exposing the data in a standardized machine learnable way. So for example, as a Parquet file or a JSON file. While when you are dealing with a data use case, you might be working more closely with a mobile app or some sort of another UI. And finally, when you're working with a data product, your consumer is most likely your colleague. While when you're dealing with a data use case, it's probably more oriented towards customers, be they internal or external.
Makes sense. Thanks very much. So there's a long-standing way of describing quality attributes in data called FAIR, which stands for findable, accessible, interoperable, and reusable. When moving to the idea of data mesh, Zhamak Dehani decided to expand that to an acronym that is much harder to pronounce, but much more comprehensive. And we'll go through them one by one. There's new attributes that Zhamak talks about. But one thing to notice is that the thing they have in common is that they're all relational. Just like our earlier vocabulary shift to language about relational terms where there are people consuming data, these quality attributes also have this idea that there is some meaningful destination for the data. So first of all, there is discoverable. So someone with a problem is able to locate data that addresses that problem somehow. Addressable. Well, I guess anyone who's used the web knows the advantages of this, but there has to be some way of identifying uniquely the data product and referencing that in other places. Understandable. So this is, again, quite a relational or subjective way of talking about it. So the data product does not just have to be abstract data that makes sense. It has to be something that is presented in a way that is understandable by human beings, because if a data product is not understandable, no one will understand it and no one will use it. So things like documentation might actually contribute here, as do things like how we name columns and how we decide to organize the data. The next attribute, the T, is trustworthy. So again, it's not just that it's trustable, it's that it gives sufficient guarantees to people that they are willing to rely on it. So often that means not so much that data quality must be perfect, but that the data quality that the data possesses is understood by the consumer, and they have confidence that whatever guarantees or SLAs the owners of the data give them are going to be upheld.
Yes, and we'll go a bit deeper in the data quality section.
Yeah. The next one is natively accessible. So ideally, data from a data product should be available in a manner that consumers are most expecting to use. So this is a little bit of a community standard, because it's not designed to say that every data product should support every possible way of access. But in a real organization, there's certain kinds of data access that consumers are expecting. So, if a consumer wants to work with SQL, ideally they'd be able to directly use that as an output port of the data product rather than having to translate a stream into a staging database themselves. So really it's about not making the consumer do extra legwork that they might not have to do. The next one, the I, is interoperable. So I don't think many people would say that data shouldn't be interoperable, but it's worth looking at the subtleties here. So part of it is how the data is stored and presented. So, how the schemas are captured and where you can find it. But also it could be subtleties about how you organize data and maybe even the language you use. So one example that I've seen come up with my clients a lot is identifier format. So if we need to identify our customer uniquely in order to join together disparate sources of data, we should agree on how we do it. And if we have different ways of identifying customers, it's going to be more difficult for us to join together that data later on. The next one, the V, is valuable on its own. So this is supposed to be an indication as to the granularity a data product should have. So if a data product is too fine-grained, let's say it's just a table with 2 columns that only have identifiers, so it's basically a foreign key relationship, then it's not valuable on its own, and it's not really easy for consumers to use. They're going to have to join it with something else before they can get any value out of it. So ideally, and somewhat subjectively, I guess, you work out what level of granularity the data product is going to be meaningful to its consumers. And finally, we have secure. So I guess it's obvious that you wouldn't want your data compromised by outside attackers, but also it's important to think about what kind of access control needs to be in place within your organization, because the idea of eggshell security, where as soon as someone has access to the data lake or the data warehouse, they can see everything, is probably not appropriate in many cases.
So Chris was just giving an overview of a lot of quality attributes. And one might reasonably ask, how do I actually make them a reality? How do I make sure that my data product actually exhibits all of these quality attributes that Chris was just talking about? So one way, and this also kind of comes from the operational way, is to treat your data product as a unit that's individually deployable. And this concept is called a quantum. So in this case, we have a data quantum that contains much, much more than just the data asset. And so this is kind of like a parallel to our operational world where we use microservices that are independently deployable and understandable. And they contain all of the information for them to be truly valuable on its own. And in case of data, that kind of means the same thing. So by not just containing the data asset, but containing many more things, you actually become valuable. And these many more things, in case of data, are metadata to make it discoverable, for example, code, policy to make it secure, and all of the infrastructure requirements to make it truly deployable on its own.
So to go back to our Nomad Nexus example, at least in the early stages, they're having some problems. So user analytics keep ranking, or worse, they work, but give incorrect results, so bad decisions get made. So for example, the mobile app was double counting users who dropped out during checkout. Flight and hotel pages had different definitions of unique user. The schema for booking change events changed, and no one realized for some time. So the CTO is stressed and looking for who can step up and fix it, but everyone is looking at us at everyone else. It's no one's responsibility. There's no kind of ownership. There's no ability of people to stand behind important data to the business and say, it's my job to make sure this works and this works well. So they're not treating data as a product. Hello everyone, and welcome to our video on moving from data asset to data product. So the reason you probably need to move from data asset to data product is that most data mesh initiatives are not greenfields. They're not people starting with a completely new system with no data and with complete freedom to plan things how they want. They're almost always moving from a current situation. And really that makes sense, because without a current situation with real data, with real value, with real pain points, really the complexity and intricacies of data mesh might not interesting to people. It would be solving problems they don't yet have. So if you're someone who is starting on your data mesh journey with a bunch of systems that maybe don't completely match the way we've been talking about data mesh in this course, don't worry, that's completely natural, completely normal, and exactly what this course is designed to address. So if we do have data assets that are important to us, and we want to have data products, how do we go about making this move? Well, this 4-part checklist is Anna and my model about how you go about it. So the first step is to make sure you can establish ownership so that there's no data assets that are lying around without clear connection to a group of human beings. Then you need to arrive at SLAs, so non-functional requirements around the data to know how it needs to be in order to be valuable. You need to have the group of human beings you've mapped to it commit to maintain it over time. Otherwise, it doesn't count as a data product because it doesn't have that element of ongoing responsiveness. And finally, you need to include not just the data itself, but all the how, all the other aspects you need that we talked about in our first video on data product.
So starting with the first step of the checklist, and that's the ownership. So when you embark on a data mesh transformation, you'll probably be in an organization that has a lot of different data assets. And they're probably in some sort of a centralized data warehouse or a centralized data lake. And most of the time, you don't really know who is taking care of the data assets or who even produced the data asset that you find inside of the data lake. So what you have to do is kind of go through the, let's say, the mission of finding an owner for each of the data assets that you have. And this also gives you an opportunity to maybe like retire the data asset. If there is like no owner to the data asset and if it's not actually needed, then yeah, maybe you can remove the data asset and then like, you have less maintenance cost. So going on this finding an owner journey is really important. Another thing to keep in mind though is that it is quite a difficult journey to go on. And you might not get a direct mapping between the data asset and one of the domain teams within your organization. So you might actually have to be a little bit creative. And this is where different types of ownerships come to play. So you might have quite a direct mapping between the data asset and the team. And in that case, maybe using a data ownership tag could be useful. Like these are the direct owners of the data and the data product. Sometimes you might have a team within a domain that has been maintaining the data asset from a technical perspective. And maybe in that case, having a technical ownership could be useful until you find a proper owner who is able to evolve the data asset into a data product. But in any case, it is important to be able to at least find some sort of a connection between a data asset and a team.
Yes, and team and not individual, I guess, as well, when we had a data owner, because in some contexts, organizations might mandate that there is someone with the authority to make decisions. We're not talking about that kind of ownership solely. We want people who can look after it. And in the context of software, that really means more than one person. So the second thing we need to talk about when we are converting a data asset into a data product is SLAs, so service level agreements. Because basically, if people are going to be relying on data, they need to have some kind of expectation about the quality of service that data is going to come with. So, for example, you could have an SLA which was freshness. You could have other SLAs about uptime. We'll talk in some detail later on in this course about data quality SLAs, which are a little bit more involved. But basically, you need to have an expectation. It needs to be something that is clear and something that a team can commit to.
Yes, and like coming up with these service level agreements can be quite an art sometimes. And there are many kinds of different SLAs available for data products. And yeah, we'll touch upon them a bit further.
Absolutely.
So the third point in our checklist is committing to maintaining a product. So it's not only important that we have an owner to a data asset. We also need a team to kind of evolve the data asset over time. So it's not enough. Most of the time, it's not enough to just produce the data asset and then making sure that it doesn't break. But it's also important to elicit requirements from your consumers and kind of, manage those requirements and evolve the data product so that it would satisfy all of the requirements that you have from your consumers. And this is how we've kind of acknowledged here as acting based on the user feedback. And that really goes into the mindset of treating your data as a product.
Sure. All right. So the final step in our 4-step process for converting a data asset into a data product is to think about the how. So when we say how here, we mean how the data gets to you. So earlier on, we talked about the anatomy of a data product, which includes things like the infrastructure it runs on, the code that serves up any behavior. It's not simply the end data set itself that is part of a data product. So I think maybe one in particular important set of things to care about are the set of things that allow this team we've identified to meaningfully commit to maintaining their data product. So that could include pipelines to make changes to production. It could include observability to work out if something is unavailable. Basically, the kind of things that you would also expect when responsibly maintaining a production system that is customer facing. And this is where, once you have all the how, it means that you've got a data quantum. You've got a logical unit of data in your organization that contains everything it needs to be successful. And then, of course, you can move on to evolving it and developing it over time.
So here we have kind of outlined how these 4 bullet points within our checklist compare between a data asset and a data product. So most of the time we see that a data asset doesn't have an owner, while the data product is maintained by a team within a domain. Most of the time data assets don't have agreed upon SLAs because the consumer of the data isn't really taken into account. While for a data product, the SLAs are defined and then measured and finally reacted upon. Most of the time, the team creating a data asset is centralized. They do it once for somebody and kind of forget about it. It just ends up in a data lake or a data warehouse. While the data product is being maintained and evolved based on user feedback. And then finally, and this is really the key difference between these two, a data asset is most of the time just a data set, a table somewhere in a data warehouse or a lake, while a data product is so much more than its data. It's also monitoring, pipeline configurations, repository with all of the code, and then finally documentation on how to use and how to maintain this data product.
Yeah, and we hope this kind of model really helps you understand where you have to invest and put effort to successfully have data products and therefore adopt data mesh. I would say that something that maybe sometimes we see with people who become enthusiastic about data mesh, maybe particularly from a management perspective, is they might just change their vocabulary and start calling all their data sets data product. That doesn't work because you really need that commitment over time to improving and responding to people's needs. So don't just change the words, change the way that you actually act.
And this checklist is also kind of a journey. So like each step adds more useful value on top of the existing data asset.
Absolutely. But the other thing we want to caution you about is, I guess we've tried to present an analytical framework for deciding what counts as a data product. And to some extent, we can give you individual characteristics, say that data products we've seen in the wild have SLAs and data sets don't, etc. But really the fundamental thing that a data product has that just plain data set doesn't have is love, right? So it has a bunch of human beings who care about it, who want to see it succeed, who care about how it's being consumed and about the use case that it's being put to. So it's that kind of that responsibility, and maybe more than onerous responsibility, that enthusiasm for doing a good job with that data that really distinguishes it. And love, like in the rest of the world, love is not something that's just a passive thing. It's an active thing that involves maintenance and commitment over time.
Yes, and finally, over the course of this video, we have kind of like given you an overview of how to go from a data asset to a data product. And the checklist kind of gives you a journey to have like a minimum viable data product. But in order for your data product to be truly great, delightful, and be valuable to its users, it needs to fulfill not just the checklist, but also all of these data quality attributes that we outlined in the previous course. And this is actually a lot more work than just fulfilling the checklist.
Yeah, and the checklist is something that you can be done with.
Yep.
Whereas this list is really not something you're ever done with. It's an aspiration that you'll continue to work on over time until such time as maybe the data product is not useful and you can decommission it.
Hello folks, welcome to the video called Varieties of Data Products. So now that we know how to move from a data asset to a data product, why not to dig a little bit deeper into what kind of data products can we actually have? Because this, after all, is data mesh, with the mesh being the key word here. And that means that all of the data products that we have within our organization should actually be connected to each other. And this is where really the value comes from. The value comes from the emergence of value from the organization based on the fact that all of the data products kind of look similar and are connected to each other and are using the output of each other.
Absolutely. So one key kind of data product is the source-aligned data product. And the purpose of that subset of data products is to bring data onto the mesh. So to take data from a situation where it might be messy, it might be locked away in a system that is not easily worked with, and exposes it in a convenient way with all the quality attributes of data products that we've discussed. So sometimes, you might have to deal with systems that don't easily respect the boundaries that you'd like to respect. They might be very large systems with all sorts of data in, and you might have to extract individual bits of that in order to make a coherent data product that is easily discoverable and usable by other people in your organization. Just as with the conventional wisdom of the data lake pattern, we recommend that source-aligned data products try not to be too opinionated. They should be constrained in scope so that the size of the data product is a good, meaningful, yet not too large and not too bulky. But also they shouldn't try to do too much judgmental joining or processing of the data, because that's best left to other data products, because in the end, just like with data lakes, perhaps the people providing the source-aligned data product don't fully understand the potential use cases that there might be in the future.
The second type of a data product is called aggregate data product. And its purpose is to add value by joining different data products together. So the inputs to this data product could be source-aligned data products or other aggregate data products. That doesn't really matter because they're all kind of exposing a similar output interface. So you can easily join them together. And in this case, you may have to deal with like awkward situations where you're joining data across different domains, and then you might have to start asking yourself who actually owns the new data product and so on. But the key here is that you need to identify at which point the data product is actually truly valuable, and whether there are some like intermediate points that could be valuable on its own and maybe would require its own data product. So a common example could be if you're dealing with a website and your user is going through the website and producing like click event data, then that could be one source-aligned data product. And then the information, for example, the demographic information about the user could be another source-aligned data product. And if you actually want to understand how your users are behaving within that website, you could create an aggregate data product that joins these two source-aligned data products that are coming from different domains into one aggregate data product that could be used by other people within the organization.
Yeah, and following Arna's point about how a data mesh has emergent value, you might hope that this customer behavior data product you've created through this join might actually be applicable in multiple contexts. And in fact, if it is used and reused, that helps to show the value of data mesh. But there is a final type of data product we want to talk about today, which is the consumer-aligned data product. And though it might superficially seem similar to an aggregate data product because maybe it pulls together different things, the purpose is distinct. So the purpose of a consumer-aligned data product is to make data convenient for consumption. So if people are from the like the world of transactional systems, they might know of the concept of back-end for front-end, right? So where a dynamic front-end application might have to get data from many places, and we build a system that pulls it all together so it can be requested and processed in a convenient way. So sometimes you have to deal with the question of whether the logic of a potential consumer-aligned data product should just be embedded in whatever use case you have in mind, right? And there's no firm answer to that. It's again just a system design problem about where you should put responsibilities together when things are too big, etc. So we'll give you no firm idea, but I guess you could think about the valuable on its own quality to be a guide as to whether any final manipulation to make things applicable to a particular use case in a data product or in the use case itself. Maybe another guideline would be if it's a kind of multi-channel situation. So Arne talked about joining things together to have a customer behavior data product. Perhaps recommendations would be an even more concrete use case specific data product you could create that could be consumer aligned. You still might need to use those recommendations in multiple places, so it's still worth extracting the recommendation logic from the UIs. But it's still very coupled to a particular application of the data.
Yeah, and this recommender system that Chris was just mentioning as a potential use case, it could be a machine learning model, for example. And the thing that we hear quite often from our customers is like, can a machine learning model be a data product? And our answer to this is usually that like, doesn't actually matter what's inside of the data product. So it doesn't really matter what's going on inside of it, like what kind of transformations there are or whether there is an ML model within it. What matters is actually the interface. And this is where we kind of call back to the initial slide that showed the mesh and all of the connected data products. And this is the important bit here. A data product is a data product if it actually behaves like a data product. Mm-hmm. So it has to have the same interface as the rest of the data products. And yeah, so as long as it conforms to a specific interface that has been decided within the organization, it can be a data product regardless of whether it's a machine learning model or if it's not.
Yeah, and maybe even that might change over time. So perhaps a team maintaining this data product might start with a simple rule-based system and then later move to an implicit machine learning-based system. And if the way the data set comes out is part of that consistent way, then the people consuming it don't need to concern themselves with the implementation details. So one thing that also comes up when we discuss this with clients is about cross-domain data products. So we've talked about how aggregate data products can pull data from multiple places and join them together to create value. We've also, I guess, hinted that one of the advantages of data mesh is it gives you a principled way of bringing data together across your organization. But then we also said that we want data products to be owned by their domains. So how do we resolve this tension that if we're pulling data together across domains, we still want strong domain ownership? Well, the first thing we would say is that when you have cross-domain joins in your data product, there's no analytic algorithmic answer we can give about who should own the resulting data product. Just like when you have, two systems that depend on, or you have a system that depends on two other systems, you've still got to decide in a technical organization who is the best place to maintain it. And that will depend on things like skill set, who is likely to have the priority for changing it over time, things like that. So there's a lot of practicalities we'd say you should choose. But also we'd say that at a certain scale, sometimes when you're starting to create these joining data products, these aggregate data products, what you're going to start creating is new domains that didn't exist before, domains that might not even have any production systems at the moment, but represent a new area of knowledge and interest and value in the business. And we'll give you an example in just a second. But so in general, you do have to have your domain-driven design hat on to think carefully about where these aggregate data products should live. But please be practical when you're making your decision.
Yeah. So as an example of a virtual domain, so if we're talking about Nomad Nexus, And we have our typical domains that are connected kind of to how Nomad Nexus operates. We could have flights, hotels, experiences, all of them like pretty basic domains that are kind of easy to imagine and easy to connect to operational systems. What if Nomad Nexus wants to start offering sustainability solutions or something like that? Like one use case could be calculating a carbon cost of a holiday or reporting internally the sustainability metrics. Where do you actually put these kind of use cases and these kind of data products? An example could be a virtual domain called environment. And you start from there and then see how that domain evolves over time.
Yeah. Hello, everyone. Welcome to our video on data product creation. So for this next series of videos, we're going to be talking about the third principle of data mesh, which is the self-serve data platform. We're starting with data product creation because for two reasons, I guess. First, logically, if you haven't created data products, you can't really do much else with them. You can't maintain them. You can't consume them. But second, we've talked before about shifting left, about moving responsibility for data left to the domain teams. And this is really the first point at which the domain teams are going to be looking for help. They're going to have something new to do that they haven't done before. And so really prioritizing data product creation as the first developer user journey that your platform supports is really important, because you want these developers in the domains to have a good experience with working with data mesh the first time they come into contact with it. So the definition of self-serve data platform is that a high-level abstraction of infrastructure that removes complexity and friction of provisioning and managing the lifecycle of data products, so that the domain teams can create and consume data products autonomously using the data platform abstractions. So a team can't be autonomous if they don't have the tools to do the job.
So when we want to create a data product, what does it actually mean? It will take us quite a lot of steps. So you can think back about like the old-fashioned paradigms of ETL and DLT and so on. You always have to ingest the data, do something with the data, and then output data somehow, like make it available for consumption. But there are actually many more intermediate steps that we'll have to take. So apart from ingesting the inputs and transforming them somehow, we also need to orchestrate the transformations. We'll need to measure data quality and expose it somehow. We'll need to make the data product secure by protecting sensitive information. We'll need to make it available for consumption, but also we'll need to make sure that it's actually independently deployable and that the infrastructure is spun up, not just for the data product itself, but also for the development teams developing it and testing it.
So for all those things, in theory, a team could take care of them themselves, right? So you could say one approach, other than having a self-serve data platform, is to let every team figure it out themselves, give them maximum autonomy, let them choose the best tool for the job. Now, the possible downsides of this are, this puts an increased cognitive load on teams, so both having to select tools and know how to use them. Lots of duplication within the organization, so you're going to have teams that will be solving the same problem multiple ways, and it's going to make your tech landscape increasingly complex. And you're going to have fewer data products because the teams are busy with non-value adding work, like working out whether they want to use Spark or Airflow or creating mappers or drivers for new programming languages that other people aren't using. So overall, we would say that if you don't have this consolidation of tooling support in a self-serve data platform, an organization adopting data mesh is going to slow down in their analytic efforts, especially over time as they get more and more tech debt.
So by shifting left, domains will get more responsibilities. And to make up for this position, we have to make sure that we give them tools to rise to the occasion. And what does it actually mean of giving them the tools, and what could be a better approach compared to the one that Chris was describing? So as a practicing data engineer and data product developer, I would like to do as little infrastructure work or as little of this repetitive work, such as setting up an Airflow or something like that, and just focus on like what's the value that I can add. Like how can I make this data product useful and valuable? And that usually means working on the actual transformations and working with the data. So it would be great if the self-serve platform provided me a service that set up all of the typical infrastructure and all of the templates that I would typically do myself. So in this case, it would be great if the platform exposed a YAML file where I would specify my data product name, all of the source information that I need, what could be the output format, what kind of transformations would I need to do for it, how am I planning on orchestrating the data, whether there is any sensitive information in it, and how would I like the access control to look like. And in the background, a lot of things would happen. So this slide is quite text heavy for a reason. There is a lot of stuff happening. You don't really need to get into it. You just need to understand that it doesn't make sense for all of the teams to be doing all of this non-value adding work themselves. And it would be great if the platform team took care of all of these integrations of different tools and exposed to them a way of focusing on value-adding work. And I think to keep in mind here is that creating this kind of service tends to be done at every company differently. And I've yet to kind of see the same way of doing this in companies. And I've yet to see cloud providers provide such a service out of the box either. So the tooling within the space is quite immature yet, and it will take us some time to agree on what could be the best way to expose these kind of cookie cutter templates for data products.
So when you do have a declarative approach, what are the benefits? Well, you get a golden path. You have domains having a chance to easily participate in the data ecosystem of the company if they take the route that is most supported, that is most common to other parts of the company. So having this path that teams can take that is convenient and also consistent really nudges people towards doing things unless they have a good reason to do things in other ways. So teams can focus on the actual manipulating of data and creating valuable data products, knowing that aspects of privacy, security, and other governance rules are embedded into the tools, so they don't have to think about them. And your organization will tend to have a unified technology stack. So this is something like the idea of a paved road or a golden path is something that has existed in the operational world for some time to tackle the problem of technical sprawl in microservice architectures. So it's also something now that we have distributed architectures in data world, we have to think about, because even though I guess experienced data engineers love to have their own preferences and maybe make their own evaluations of tooling on wire things up in a way that is particular to their opinions, most of the time that's not really necessary, and it would be better if there was a golden path that the whole organization could be encouraged to rally behind and that tooling investment could be focused around.
Yeah. So in summary, what we would like the self-serve platform to do would be to reduce complexity and cognitive load through declarative modeling and automation. Declarative modeling would allow the developers to easily describe what they want to achieve, while using automation allows the platform to reduce the complexity and the possibility of developers making errors while implementing whatever they wanted to achieve. So like Chris mentioned, both of these ways of working with complex systems are actually quite used in the operational world as well. And if you want to see an example of declarative modeling, then infrastructure as code is a good one, because these frameworks have been popular for quite a while. And they're really useful as well. And for automation, CI/CD pipelines are quite an easy example as well, because these are quite complex workflows. And by automating, we're actually able to speed up the teams by quite a lot and reduce the number of errors that people could make while deploying their services.
Yeah, not so much even fixing errors, but making those errors impossible to make because the process has been embodied in code.
Hello folks, welcome to our video on discovery. So imagine yourself being a data analyst or a data engineer within an organization who gets a request from the business to build a new dashboard to reflect some changes within business KPIs. The first question you'll probably ask yourself is like, what kind of data should I be using and where can I get it and how do I get access to it? That's one use case. Another one could be by imagining yourself being an ML engineer and needing to build a new predictive model. And in that case, you still probably have the same questions, like where can I find the data? But you'd also have to dig a little bit deeper and start asking yourself, is the data that I have found actually trustworthy? Does it have any biases in it? Can I actually use it for this particular model? So the questions vary from whether the data is high quality to whether the data is actually suitable for your use case. And when you start asking these questions, you also start making trade-offs between like, should I reuse the existing resources within the company or should I build something new? And when people don't have trust in data, when they don't find data that's exactly suitable for their use case, there's a big tendency to want to build things. And this, of course, takes time and resources. So data discovery is about like answering these kind of questions and figuring out a better way to reuse data products within an organization.
And we want to emphasize that when we're talking about data discovery, we don't just mean that you need to discover the syntax of data. I guess that is important, that kind of metadata, the schema of it, the format, what do the columns mean, what do I need to parse the file? Those things are important if you're this ML engineer or this data analyst. But it's also important to understand the meaning of the data, the quality of the data, the temporality, the governance, I guess in a sense, the context, who's standing behind that data, because it doesn't do you any good to discover data that has the right schema, but to later find out that perhaps that data is no longer supported and it's going to stop or change schema next week or tomorrow, or there's something about the details about how that data is produced that makes it unsuitable for your use case. So when we're talking about data discovery, it's about finding data that matches your use case, and that's more than just the hard bits and the XML and Parquet schemas.
Yeah, so based on understanding what is the metadata that we're looking at, we do have some common user journeys within the data discovery domain. And these journeys always consist of like some personas pursuing some use cases. And the easiest example actually is a data engineer consuming data. What would they have to do? Usually they would be searching for a data asset or a data product that would help them accomplish their goal. Once they've found something, they need to verify the trustworthiness of the data through the use of all of the additional metadata that they can find, such as data quality or lineage, which basically shows you how the data flows through different data products, or even SLAs, which allow you to see whether the expectations for the data have been met. Once they've found the data, they will need to request access to it. But before doing that, they might also want to dig a little bit deeper into the data to understand whether it truly fits their use case. And to do that, they might want to explore the data a little bit more.
Cool. So that's the obvious use case, find data to use it or to reuse it. There's a couple of others you might want to think as well when you're designing how data discovery works in your organization. So another one that is obviously vital is that as a data engineer producing data, I would like to collaborate with data consumers on making a better product. So if you're someone who has spent a lot of effort on assembling a certain data set or doing some particular processing or cleaning, it's in your interests to help other people use it and get more value out of the investment that you put in. Another example of a persona that's relevant in data discovery is people working in governance. So as an organization, I would like to govern metadata and thus data, and that help me make available high quality, consistent, compliant data, respect people's privacy, and minimize risk for the business. So that kind of third party to the data producer consumer relationship is also very important in a data mesh. And I think maybe you could empathize a little bit with people who are involved in governance, that there's nothing more disconcerting than supposedly governing data in an organization when you don't know what's out there, you don't know what's behind it, you don't know who owns it. So that ability to discover it so that you can protect your organization from risks around data and data usage is a really valid and really important one for data discovery.
Yeah. So in our opinion, data discovery is becoming less about finding data and more about matching data with your specific goal or use case in mind. And why are we saying that? In our opinion, like in the past, before data mesh, the goal of data discovery was mostly to find high quality data within the big pile of rubbish that could be the data warehouse or a data lake within your organization. Without a data mesh, the goal has changed slightly. And that's because the data products have to actually fulfill many quality attributes that would make them actually great data assets. And that means that by default, almost all of the data products within your organization will be high quality data products. And the goal of data discovery will be finding the best data product to fulfill your goal.
So earlier in another video, we warned that the tooling for data product creation is still immature. You might find yourself rolling things within your organization that ideally you'd hope to buy from a vendor. And now in the data discovery and data catalog world, well, it's still a rapidly evolving space, but there are options. And I think we would recommend that if you find yourself being a long way into your data mesh journey and kind of custom building your own data discovery or data catalog solution, would encourage you to think that maybe you're putting your investment in the wrong place and you should consider something that already exists. So some examples that already exist, Calibra is kind of an enterprise choice, very sophisticated, very flexible, maybe comes with the heavyweight implications of something that's designed to be enterprise grade. Atlan is a newer example of a vendor that's got some interesting ideas. I think Arne and I have a special affection for Data Hub, an open source solution, partly because it shows that it's not just vendors, it's the open source community who is doing this, but also because the user experience of Data Hub has started to incorporate data products as a first-class concept. So we think that now, but also over time, is going to make it easier to work with Data Hub and Data Mesh.
So as Chris mentioned, the tooling is still evolving quite rapidly. And most of them suffer from really common drawbacks. The chief among them is that most of them are still pull-based. And what that means is that if your organization needs a data discovery tool, there will be a team, probably a centralized team, setting one up and then starting to connect it to all of the data sources available within your organization. And then the tool, the catalog, will start pulling all of the data in. Within data mesh, we think that that's not the best approach because it's creating this big bottleneck, basically, and centralizing the responsibility. In data mesh, data product is actually the one entity responsible for making itself discoverable, because a data product is actually supposed to contain all of the metadata necessary for it to actually be discovered. So instead of a pull-based mechanism, there should be a push-based mechanism with all of the capabilities embedded within the data product to make it self-discoverable. Additionally, most of these tools lack support for data products and everything that comes with them, such as SLAs and other quality attributes that we outlined earlier.
Hi everyone, welcome to our video on observability. So observability in a data context is the capability of a system to generate information on how data influences its behavior, and conversely, how the system affects the data, right? So you could be thinking you could have a data pipeline or a data product. Since we're in data mesh, there's data flowing through it. That data coming in could affect how this pipeline can behave, what's going on, is it working, is it not working? But also the computation in the pipeline and the data product affects the data coming out of it.
Yeah, so with data observability, you'll be trying to answer several questions. The first among them being, is my system actually available? And also, is the data within the system available? But that's not the only question that you should be answering. You should also be asking whether the data and the system is meeting the expectations that have been put in place by the various stakeholders. And part of it will also be answering the question of whether the data and the system are available, but that's not the only question that should be answered. And then the wider question will be what's actually going on within the system.
Yeah.
So if something goes wrong, then like what's going wrong? And then data observability should be guiding you when you will try to figure out like why are things going on wrong and like how can we fix them.
So the three pillars of observability are often known as metrics, logs, and traces. And this is still true in the data world, but I think that both in the operational and the data world, we have to be a bit careful with how we describe what we mean by observability. So monitoring is something with a proud history, which is just, we have some kind of access to the system to tell whether it's up or not, and that kind of corresponds to the last slide where Arne was talking about this baseline of system availability. But when we talk about observability, to really do justice to that term, we have to be able to ask unexpected questions and explore what's going on. So the raw material of what we're doing is metrics, logs, and traces. But to achieve the observability means we have to build more on top of that.
And the more on top of that are actually the rules that the system should be following. And in his book, Andy has created the following taxonomy. And let's start from the bottom because that's a little bit easier to start with. So on bottom left, you can see a variable dropping below a threshold. So that means that we're just measuring one point in time and we're comparing it against a particular constant variable. So like from the operational world, you could take an example of like CPU crossing 80% or something like that. Like maybe that's when the system performance becomes critical. But that's not the only data rule in place. The pace of the variable change could be something of interest to you, and that's the quadrant on the right on the bottom. So that's one specific variable that we're measuring, but that's not the only thing that we should be concerned about. We should also be concerned about the relationships between the variable in a single point of time and over time. And I think the most interesting thing is like how the variables within the system work in relation to each other. So sometimes when you're looking at business KPIs, maybe the difference between multiple variables is actually something that gives you a lot of information about your system. So if the difference between multiple variables becomes too high, then that might actually tell you that there is a problem within data sources and the system is not behaving the way it's supposed to behave.
So why is data observability important? Why have we chosen to make a video about it? Well, a good data observability suite will help you reduce the time it takes to detect an issue, reduce the time it takes to fix an issue, validate and decentralize the management of data quality, a very important thing in data mesh, including the measurement of SLAs and SLOs. So we've talked about SLAs and SLOs before and how important they are. Well, data observability and the data rules that Arne mentions gives us a way to compute them and to actually operationalize them. And finally, it supports governance efforts. So, in data mesh, we're very keen not to make governance a manual process that involves individuals inspecting it. We want to be able to set up automation that makes that easier and that can do the job while the humans are asleep. And data rules and data observability really help us to do that.
Additionally, you might ask, okay, data observability is important. How should it actually look like? And there isn't really a clear, all of the clear patterns within the industry of how to do it. There are certain tools available that can help you, but a lot of the time you still need to put the building blocks together yourself. And what we recommend is that whatever you use or whatever you come up with is easy to get up and running by your platform team. There should be consistent ways of measuring observations across your different data products. So that again comes back to the idea that data products should look similar and the interfaces should be the same. And then additionally, data and operational observability should all be integrated and harmonized. They should be working in similar ways, ideally even coming from the same platform team. And then finally, all of the context-specific data rules, they should be delegated to the team, because it's only the team that truly understands the relationships within the data and that actually knows at which point in time the system could misbehave.
Yeah, which is a lot of the point of data mesh when we talk about distributed ownership. So we want to come back a little bit to something we mentioned early on in the course, which is different models for managing data with an organization. So we talked about one of the key drivers of data mesh being the phenomenon where data pipelines, data products, data use cases are things that our consumers are depending on, that have to work over the weekend, that if they get interrupted, it becomes an immediate business need to address them. So that's true either in a system where you have an as a service relationship where you've set up some kind of data API and you've got a contract and promise that you're going to keep to that contract. You need to have data rules and data observability to substantiate that, and maybe also to substantiate the fact that if there's a problem, it's elsewhere in the system and not your fault, so you don't get woken up. But also if we want to have a data product team that's existing in the domains, that is self-sufficient and has all the skills it needs to create its own data products, well, part of those skills and part of that necessity is being able to support it. So those teams need to have a convenient enough access to data observability and creating data rules so that they can be confident that with all the other things they have to do as well, that they can support their data product in production and be confident that if there's a problem with it, their observability is what's going to discover that problem and it's not going to arise from the complaints of customers.
Hi folks, welcome to the section on computational governance. So this is the last principle of data mesh, and as always we'll start with the definition. So federated computational governance is a governance model that embraces decentralization and domain self-sovereignty, interoperability through global standardization, a dynamic topology, and most importantly, automated execution of decisions by the platform, so that data users can get value from aggregation and correlation of independent data products. The mesh is behaving as an ecosystem following global interoperability standards.
And in this video, we're really going to focus on that automated decision-making because, we have talked about the federated nature of data mesh before, which is the domain ownership. And I think governance is a concept that is well known in the data world, but why computational? So the idea behind federated computational governance comes back to something called a fitness function, as discussed in the architectural world. So from the book Evolutionary Architecture, we have the idea that a fitness function is an objective function used to summarize how close a prospective design solution is to achieving the set aims. So there's, I guess, two important aspects to that. One is that it provides an indication of what good looks like so that people can self-organize and use autonomy in local decision-making. And the other thing is it's automated, so it doesn't depend on individual judgment that might not scale very well.
So you might be more familiar with the traditional way of managing governance rules within an organization. In that case, you usually have some sort of an individual, like a data steward or some sort of a committee approving changes to individual data sets. In that case, the problems are usually discovered during an approval stage or even after something has actually gone wrong. In cases of computational governance, so within the data mesh paradigm, we're mostly governed by rule. So the teams can actually discover the problems themselves, and the governance is a continuous process that never really ends. So in a sense, we aren't really managed by people or individuals anymore, but the teams are managed by rules.
So when you're trying to create systems to influence people's behavior, which we are with federated computational governance, there's a few ways you can do it. You might nudge them, which means that you use your powers to make doing the right thing easier. So you don't mandate or force anything, but you encourage the right thing. You attract people towards the kind of things you want. You might have some kind of alert process where if there is a problem, it's made visible and either the person or team themselves or someone else can address it. Or you might use something that is called poka-yoke, which comes from Lean and the Toyota production system, which means that you make mistakes impossible. So this last one, I think, is a really powerful concept. You might consider the difference between USB 2 and USB 3. Maybe we've all had this experience of a USB 2 trying to put it in the plug and finding it's the wrong way around. So, basically there is a way to make a mistake. It's not obvious and we're constantly making that mistake. Whereas in a USB 3, you can fit in the connector into the socket whichever way. So mistakes are kind of not so much prevented as made impossible by the system. There is no mistake to be made anymore. And really that's the golden standard for this kind of thing, because it allows you to just not even worry about whether you're doing the right or wrong thing and just get on with your job. And that's what we want from federated computational governance.
Yeah, now let's try to go through some of the examples and illustrate all of these types of influences on Gnome and Nexus. So let's start with the first one, nudge. So let's assume that Gnome and Nexus has their domains down and they're actually now creating data products.
Mm-hmm.
How should they start? So the platform team at Gnome and Nexus has decided to do a starter kit, some templates in Scala. That's going to be the way that the new data product teams can deploy a new data product. So they just take the template from the data platform team, they use Scala, and they deploy everything in one go. It's not really impossible for them to write their data product in Python or Ruby or anything else. It's just a lot more troublesome. So we kind of talked about this concept already in some of the previous sections, because in this case, the platform team is nudging the data product team by providing them a golden path or a paved way of doing things. So they're providing a data platform service that allows them to do things in a particular way that they've imagined.
Absolutely. So you're much more likely to get consistency in that organization. So another one we might have is alerting. So data quality rules are a good example of this. So now that Nomad Nexus has started to produce data products, they've instituted a rule where every data product must specify a freshness data quality rule, right? So that's one of the concerns that applies to pretty much every data product everywhere. So if the data product doesn't live up to its freshness rule, it's marked as stale on a dashboard and the owning team is alerted, right? So the data product isn't taken offline, it's not automatically deleted, there's not a robot that goes around and tries to update it, because it's something that requires human attention. It's not really possible to fix in a hands-off way, but it alerts people to say that something should be done, and either the team themselves or maybe a manager, if the team neglects their responsibilities, can go and fix the problem. So that is another way that we have an automated process influencing people's behavior.
And finally, sometimes the concerns that your organization may have may be that big, like, for example, dealing with PII information or other kinds of sensitive information, that you would like to put your data product teams in a situation where they can't really make a mistake.
Mm-hmm.
So, for example, when dealing with PII data, the data platform team should provide tools which would make it impossible for the teams to actually create a data product without specifying whether the product has any PII information inside of it. And even if they, for example, like mismark their data set, there should be tools available that would scan the information within the data product and notify the team whether they're in compliance or they've made a mistake. So this would allow you to actually make it impossible for the product teams to mislabel their PII data. And, well, that's kind of part of the story, but also the data without the PII data should be fully available to everybody. And the data with PII information should be subject to stringent access control measures, and it should be tightly controlled so that people who shouldn't be viewing that information should never even be in the position where they can view it.
Absolutely. The other thing we want to say, though, is that it's okay to have rules that are written down in natural language and that everyone agrees to follow, right? So we're emphasizing that it is valuable to automate rules because it empowers teams, it allows for continual governance, it allows them to check their own work rather than asking for someone else to come in and tell them if they're doing the right thing or not. But sometimes there's stuff that just, it makes more sense to have a rule about, and no one needs to be ashamed about that. So, for example, all data products and operational systems in Nomad Nexus have to respect the GDPR right to be forgotten, right? So if someone says, I don't want you to have my data anymore, please delete it, and they have to do it. Just because we might not have a good way to automate a check that this is actually happening doesn't mean it's not important for it to be a rule. It's very important from a legal compliance point of view that people are doing this. And it's okay to say this is one of our lists of guidelines. This is one of the non-negotiable things you have to do when you're building an operational system or a data product. So automate as much as you can, but if it can't be automated, that doesn't mean you can forget about it. Hello everyone, and welcome to our video on data quality. So let's start with a definition again. Moses Gavish and Forwork define data quality as a function of measuring the reliability, completeness, and accuracy of data as it relates to the state of what is being reported on. Now, I guess you'll find quite a few different definitions of this, and we'll actually decompose data quality into a few more dimensions later on. But this is a really good working definition that gives you an indication of the different aspects of data quality. Like it's something that you need reliability, completeness, and accuracy for before it's going to be useful to your consumers. But an informal way of putting it is that data quality is the health of data at any stage in its life cycle.
So why is data quality important? We know that since we're talking about data mesh, the best data products are the ones that are connected and power other data products. You will only be using other data products as your sources when you have trust that they are actually giving you reliable and accurate information. And in order for this trust to be formed, data products need to actually push some sort of information to make sure that this trust can be built. And data quality metrics can be one way of doing this.
Yeah, so you can see that data quality doesn't just have to exist, it has to be known to exist for it to be used in this evaluation process. So we have to actually demonstrate what's going on. So how do we measure the health of data? Like what are the different elements we might do? Well, I'll go through a little bit of a list that tries to cover common things that you might want to measure. Accuracy, that data represents accurately the reality that it's designed to reflect. Availability, the data can be accessed when you need it. Completeness, so the data, it hasn't got missing observations and it has all the dimensions in each observation that it's supposed to. Consistency, data processing follows consistent patterns of ingestion and transformation. That's an interesting one because, just looking at the data itself isn't enough to tell you whether it's quality, right? Something about the history of that data might be quality or might have data quality problems. And finally, timeliness. So data is sufficiently fresh. So the right data at the wrong time might not actually be useful to your consumers. And, it's interesting. You can think that how fresh data has to be is very sensitive to the particular use case we're talking about.
So, as we know, data products work best when they actually fit your use case. The same is true for data quality KPIs. So in some organizations, the data accuracy actually has to be numerically high. In some other cases, it's not actually that important for it to be that high. So how do you actually measure these KPIs and which values make sense for them? So for that, a very useful tool is setting service level agreements or SLAs. They help businesses set expectations for the data and identify when something has gone wrong. In order to verify these expectations, we're using the following 5-point bullet list that one of our colleagues, David Rubio, has come up with. And these 5 points are, so first, we're associating data with a use case, with explicit business needs. Then we're defining some data quality expectations or service level agreements based on these use cases. Then we're categorizing these expectations per data quality KPI. Then we're defining measurable service level objectives for each of the SLAs. And finally, we're monitoring them through the dashboards.
All right, so let's walk through an example with Nomad Nexus, because that's a fairly dense list in the abstract. So let's take a carbon footprint dashboard as an example. So the need might be, I don't know, how often is it used? Maybe once per hour. When is it used? In the European time zones. How many people or services use it? Thousands. How accurate does the data have to be? Well, it needs to be measured according to accepted standards for it to be credible that we're displaying carbon emissions. And how fresh does the data have to be? Well, it has to be within hours, right? It doesn't have to be accurate within milliseconds about what your carbon footprint is.
So once we've had the conversation about how the data product is going to be used, we can start writing down the SLAs, the expectations, essentially. So the first one could be that carbon emissions are in line with scientific estimates, and that will be connected to accuracy. Then we outline an expectation that the data has to be available within European business hours, and that, of course, is the availability KPI. Then the third one is that the carbon emissions are calculated for every stage of the customer holiday. This will be completeness because we're talking about the dimensions required for the data. Fourthly, we might have an SLA that says that carbon emissions are processed each time a third party sends new data. So this will be consistency. And finally, we might have an SLA that says that carbon emissions dashboard is updated every hour. And this will be connected to a timeliness KPI.
Cool. So let's drill down on the accuracy one. I don't think we need to go through them all. So if we have the SLA of carbon emissions are in line with scientific estimates, then the SLO can be that the carbon emissions estimates are within 10% of the values reported by a particular ISO standard for at least 95% of the products in the dashboard. So you're making it specific, objective, whether or not that's true. So that's an SLO, and so that's something that you can measure whether or not you're meeting.
Yeah, and once you have a long list of all of your service level objectives that are clearly measurable, you can actually aggregate those measurements together and visualize how your data product is meeting all of the expectations. So on this slide here, you can see like a snippet of the aggregated measurements for each of the data quality KPIs. And this way, the stakeholders or the consumers of your data product can actually see whether the data product is meeting the set expectations and whether it should be trusted.
Yep, so we don't just have quality, we demonstrate what quality we have.
Hi folks, welcome to our video on data privacy. So why should one care about data privacy? And not just because there are huge fines out there if you violate data privacy. So data privacy is important because a lot of the data that's currently being processed by many organizations can be sensitive. It can be sensitive both for individuals or organizations and institutions. So most of us are probably aware of personally identifiable information. So that's information that can actually identify an individual, such as their name, their address, their email. There are also some information that's sensitive, but it's personal. So data about person's interests or online behavior. So sometimes a data point that can be personal, such as me living in Spain or me shopping at a particular shopping mall, can be personal, but not identifiable. But if you gather a lot of these data points that are personal, you might actually be able to get some information that's identifiable. On the organizational level, you have a bit of a different story. So some of the information can be confidential, such as a strategy that might give competitive advantage if it leaks. Some of the information is licensed, such as commercial or contractual restrictions. But all of this sensitive information should have its own data classification policy, and it should be protected accordingly.
So one of the most important elements to treating sensitive data correctly is consent tracking, because it's not enough just to have possession of data to be able to use it. It's not even enough to have possession of data and permission to use the data. What you need is possession of data, permission to use it, and sufficient evidence that you have permission to use it, and in what ways. So what do we mean by consent tracking? So understanding the provenance of the data, where did it come from, knowing the versions of the privacy policy and the terms and conditions that were used at the point where this data was collected from users, for example, in a web form, the individual preferences of that user. So what did they consent to? Maybe they said they were okay with a certain usage of their data and not with another. And remember, under GDPR, it's now our obligation, if we work in that context, to be specific about the consent we collect. And finally, when was this consent given? So you need to have all this information if you want to be confident that you have the sufficient permission to use the data correctly.
So even if we have consent on processing data, it's not always a straightforward way to achieve it. So we would always have to kind of balance the trade-off between privacy and utility. The more privacy guarantees we want to achieve, the less we can actually use the data. And the less privacy mechanisms we apply, the more we can use the data. But that might not actually be legal all the times. And on the spectrum, you have a bunch of different mechanisms that are somehow in the middle of it. So erasing data gives you more guarantees, but doesn't allow you to really use the data as well. While encrypting the data might actually give you more ways of using it, because some encryption methods are actually not that secure or private. Most of the time, people or organizations tend to gravitate towards anonymizing data. And the traditional ways of doing it, such as removing certain data or aggregating or masking data, can actually be reverse engineered. So for example, aggregating data. You can still, in certain cases, understand what kind of information you're actually aggregating there.
Yeah, absolutely. So it's kind of common in the industry to talk about anonymization when really it is obfuscation because of that reversal effect. So if we consider the example of a company that has salaries that are different for different people, obviously. If you have the average salary for that company, you might say that that doesn't compromise anyone's privacy because, I don't know, there's 10,000 people that work for the company, so you can't tell anything about a person. But if you knew the average salary the day before someone joined the company, and then the average salary the day after someone joined the company at sufficient precision, you could actually reverse engineer what their individual salary was. So that's an example of where aggregation is obfuscation. It can reduce the attack surface of the data, but it doesn't actually provide guarantees. So if you want to have guaranteed anonymization, the gold standard at the moment is differential privacy. So that's a mathematically rigorous technique for managing privacy through the lens of managing information leakage. So someone who's querying or attacking the data can acquire a certain amount of information, and the question is whether they acquire excessive information about an individual. So it's suited to the data mesh paradigm because this is a relational concept. So you have a consumer of data, you have the producer of the data, and it's the relationship between it, which is how we conceptualize this protection mechanism. The way it works is by injecting carefully crafted noise into the response, which prevents an attacker from reverse engineering privacy about a specific individual. So it raises the uncertainty of an attacker about exactly what's going on so that they can't do that reversal. So 10,000 people salary, if there was a little bit of noise injected there, it wouldn't be possible to do that reverse engineering attack I mentioned of measuring a salary average before and after someone joins. There'd be a little bit of uncertainty that would prevent it.
So this equation basically summarizes what Chris was talking right now about differential privacy. So think back again on the example of the salaries. You have two databases, one before adding a new row and one after. By injecting the noise into the database and into the query, you're able to achieve a state where the attacker accessing these databases would have a very low probability of understanding which of the databases is the before one and which of them is after. By injecting the noise, we increase the privacy by a lot while still keeping the utility of the databases quite high as well.
Yeah, and so this is quite a specialized technique. It is suitable for cases where you need sufficient guarantees of privacy because, it provides a rigorous guarantee that you can measure, but we're not suggesting that every data product needs something like this. It really depends on your context. So actually, we want to mention a couple of techniques like this that might be suitable if you need the federated computational governance of your data product collection to supply that poka-yoke, so to make it impossible for privacy to be compromised. But yeah, you or the team managing that data product will have to decide what is proportionate to the use case. So some emerging techniques that you could think about using. One is federated learning. So this takes place in a machine learning scenario. So rather than shipping all the data from a mobile device that's being collected or an edge device to a central location and then training the model, what happens is the training of the model happens at the edge, at the mobile device. And then what's shipped back to the central location is the weights. So the original data is never actually present in the centralized data location, so there's no risk of that being compromised. Another example, which is, I think, a bit more futuristic, is encrypted computation. So there are techniques where it's possible to transform a computation so that you can run it on the encrypted value directly, avoiding that decryption, processing, re-encryption cycle. So for some use cases with sufficiently sensitive data, or I don't know, maybe a threat model that is sufficiently dangerous to that data, that might be proportionate. But of course, you'll have to decide in your own use case. The final one, we listed as emerging because I think it's something that is still maybe emerging in people's consciousness, but it's not really been invented recently, is minimizing the data collected. So in data mesh, we try to encourage ownership of data near where that data is collected. Now, one of the ways that can be really useful is that the people who are running the operational systems that are collecting the data can be brought into the conversation about what data needs to be collected for what purposes. Maybe the best way to handle a certain set of sensitive data is to never collect it in the first place and adjust the user experience so that that's not necessary. And that's much more possible in a data mesh scenario where the data world and the direct interface with the customer are brought together without intermediaries of data organizations.
So we've talked about how to design data products with privacy in mind, but a lot of the organizations will actually find themselves in a situation where they have a lot of this kind of dark data for which we don't really know who is the owner of it, or where was it gathered, or whether the consent was recorded. So in that case, what one should actually do is to start by investigating the provenance of the data. So when was it recorded, how was it recorded, from whom was it recorded, and for what purpose? Once that's done, one can try to determine the sensitivity of the data, so whether it contains any personally identifiable information or any other kind of sensitive information. And then finally, you have a choice to make, whether to delete the data, whether to archive it and stop using it, or whether to evolve it into a proper data product and maintain it.
So to illustrate this process of documenting dark data, we thought we'd return to Nomad Nexus. So if you recall from earlier on when we talked about the architecture of Nomad Nexus, you might remember that they acquired a travel experiences company. Now that travel experiences company came with a database of testimonials, so names, ages, and photographs of people who've been happy customers of this acquisition services and were happy to recommend it. Some of these testimonials were uploaded by travelers to the website. Others were uploaded by the guides, so the people who are running these experiences. Now, the tricky thing here is that Nomad Nexus was able to establish consent for the directly uploaded data by the travelers because it happened through their website. They could work out what the terms and conditions were. They were confident that that gave them legal clarity to use that data in the future. But the data that was uploaded by the guides on behalf of travelers, because they didn't really know anything about how the guides had collected that data and the guides weren't contactable or able to substantiate that they had permission to use that data, Nomad Nexus was unable to establish confidence that they had sufficient consent for that data. So in the end, they decided that for avoidance of legal risk, they needed to delete it. Hi everyone, welcome to our video on working backwards. This is the first video in our section about how we're going to help you put data mesh into practice. The lessons we've learned practically working with data mesh on what you need to do to take the theory that we've discussed in previous videos and make it into a successful program. So one of the most important artifacts we think you can deploy to get started in data mesh is something called the Data Mesh Accelerate Workshop. So it was documented by Paolo Caroli and Steve Upton and is available on Martin Fowler's website as a blog post, but we're going to run through today the important elements of that, which is a process of working backwards from your desired future state to what you need to start with. So the first step in the Data Mesh Accelerate Workshop we call Data Mesh Nirvana. So that's a process where collaboratively with people who are expert in data but also expert in the business priorities around data are gathered together, and they might use various practical ways to generate ideas and then consolidate. So that might mean putting stickies on a whiteboard and voting, or any other facilitation you might want to think of. So for example, in the Nomad Nexus case, we might have a couple of candidate visions like we empower customers to make decisions consistent with their values, right? That might be the aspiration for what data means in Nomad Nexus's context. Or another one could be we anticipate our customers' every need. So, we send them predictive suggestions for holidays they didn't know that they didn't know in advance they wanted to do. But in this particular case, in this hypothetical workshop, it's that empowering customers to make good decisions that is most consistent with Nomad Nexus's vision.
So once we've defined our nirvana, our target state, we need to make sure that we're able to measure whether we've successfully reached it. So in the case of, in this case, we'll have to come up with some objectives and key results to properly measure the target state. And in the case of Nomad Nexus, if customer satisfaction is our goal, then customer loyalty could be one of the objectives that we target. And the measurable key results could be the percentage of booking from the repeat customers, or bookings from the referrals, or social media mentions.
So now we have a way of establishing whether we've been successful. We need to explore use cases that might help us move the dial on those numbers. So a couple of the suggestions that came up in the hypothetical Nomad Nexus example are an impact score. So a lot of Nomad Nexus's customers are ethical people who are conscious of the impact they might have while traveling. So being able to give them information about that could be a way of helping them to make good decisions. Another idea might be to help them generate an Instagram post about their holiday using generative AI. And of these two examples, I guess a generated Instagram post could be fun to work with generative AI, but actually that impact score, surfacing that customer analytics back to the travelers with Nomad Nexus, was considered most in line with their strategy and with their business's values.
So yeah, once you have the use case in mind, you'll actually have to work towards creating the data products that will fulfill that use case. So a use case might have one or more data products associated to it or powering it. So in case of the impact score, you might have to come up with a holiday carbon count data product, or take into account the way that people actually want to visit cities or tourist places. And that could be your gentrification index, for example.
Cool. So that's a flow, a cascade that's gone right from your aspiration through to what practically you need to do to get started. Now, what if it isn't so smooth? What if you stall in this process? So in our experience, what this means is one of three things. Either data isn't a genuine priority for your business. So when people are trying to come up with a vision, they fail because there isn't a vision, and maybe that's okay. Another alternative is that you just don't have that vision clear, right? So maybe you do have some kind of aspiration, but you need to talk more to work out how that vision will be realized within your company. Or maybe more often, you don't have the right people in the room. So maybe you accidentally only invited people who are currently working in the data department. and no one from the business who's in touch with what customers are demanding. Or maybe the reverse. You only have people who have product aspirations but don't have any knowledge or understanding about what kind of data Nomad Nexus or your own company might have or what it can do. So in any case, if you can't establish that cascade from vision to OKR to use case to data product, our suggestion is that you don't proceed. You either need to pause or talk more and involve more people in the conversation, because if you don't do that, you run the risk of beginning your data mesh journey based on something that isn't actually valuable to anyone, and that might be convenient in the first few weeks when you don't have people tell you what to do, but it's going to rapidly undermine the political support for your initiative, and you're going to find yourself in trouble.
So the Accelerate workshop kind of covers the first two layers of this cake, which is basically the use cases and the data products. But in order for you to make those data products a reality, you have to consider more, as you might imagine, since you've been watching these videos. So in order to make data products a reality, you also need to make sure that the platform can support them, and then that the organization actually has good enough governance in place for you to be able to continue making more data products. So at the start of your data mesh journey, you need to make sure that you kind of have this thin slice of the use cases, data products, the platform, and the governance. You need to have the seeds of all of them to make your journey a success.
Absolutely. Thanks very much.
Hi folks, welcome to this video on kickstarting governance. As you may remember, the goal of governance within data mesh is to come up with certain global policies within the organization, and then for the domains and the self-serve platform to implement these. So what should one do to kickstart governance within their organization? Our experience in different organizations has been the following. We see that organizations go through these three different steps. They first constitute the governance body, then they define the appropriate governance policies, and then they start implementing it. Pretty straightforward, actually, right?
Sure. Well, constituting a governance body has maybe got a subtle difference in data mesh. So firstly, we should reuse existing structures if there are any. So we shouldn't create a separate kind of governance concept that has no relationship with how we run the business now. But secondly, and maybe more importantly, we need to make sure that all the domains and functional areas like security, legal, and also the data platform are represented. And that representation is key to our method. What we want is for these groups of people to come together and discuss what kind of cooperation they need in order to build an effective data mesh, and to capture those cooperation rules in governance, right? So governance is not governance for its own sake. It's to make it easier for the people in the mesh to build great things. So, for example, maybe someone from the data platform part of the organization will say that if only we can agree to be consistent on a certain implementation detail, then it's going to be much easier to build the platform and maybe offer more advanced features. Or maybe someone from one of the domains is going to say, well, if we can just agree on how we identify each individual customer, then we don't have to do so much mapping and back and forward between different domains, how we identify customers. So these kind of things are typical when you have a functioning governance process that treats governance as a tool for people to work together more effectively. Once you have that representative body, you need to get started, and that means creating a backlog for the governance body. Doesn't mean you have to do everything up front. You can create a backlog and start on the most important things first. And then it means you focus on the what, not the how. So focus what the interface of teams and elements of the data mesh need to be to achieve that cooperation. Don't focus on trying to micromanage each other and how you get your job done.
So one of the first things that we usually see organizations defining when they start their governance journeys is what would the data product actually be for their organization. Quite often you might be tempted to search for this definition from Zhamak's book or some other authoritative source, but there isn't really one, because a data product or how a data asset transitions into a data product is actually highly contextual, and it really depends on your own organization. So on this slide, we have an example of what could be a simple checklist for defining a data product for your organization. So you may mandate that a data product should have a unique name and description. It should belong to a domain. There should be an owner assigned. The data access requirements, so who and under which conditions can access data, they should be clear. And then also the access mechanism, such as whether it's accessible by SQL or API, should also be clearly defined. And again, these are kind of requirements coming from the governance body, but they should be implemented by the self-serve platform.
Right. So when we come to kickstarting the implementation of the governance, we have to think about mechanisms we can use to change behavior, because if governance doesn't influence behavior, then it's not useful to anyone. So recall when we talked about the self-serve platform, we wanted to automate things. We didn't want to inspect everything by hand. There were 3 different strategies we discussed using to influence behavior. So one is a nudge. So maybe if you offer a starter kit as part of the platform, that puts people on the right path, the golden path, towards using the right technology in the right way. Maybe if we have alerts, for example, monitored SLAs, it creates a kind of hopefully a reasonable peer pressure for people to make their data products conform with the SLAs they promised. And finally, we have poka-yoke, which is the ideal, which means that we've created a system such that mistakes are not possible. So maybe we fold in the creation of certain elements of a data product into that data product creation itself, so it's not possible for teams to make mistakes by omission. Once we've got that, we need to track governance policy adoption through automation and fitness functions. We don't want to make people involved in governance have to run around and inspect individual teams and keep track of what everyone's doing. It should really be an automated process. Hi everyone, and welcome to our video on minimum viable platform. So just to recap, a self-serve data platform is supposed to empower domain teams autonomously to create and manage data products, to allow users to discover and consume data products, and to do it all in a secure way that's consistent and compliant with the organization's governance policies. But that's a big mission. That's a lot of stuff there. That doesn't mean that we immediately have to jump in and build a massive platform. We can actually do it gradually.
Yeah, so quite often when an organization is starting on a data mesh journey, they might think like, what would be the best data platform to support this? Like, can I buy something? Do I have to build it? And yeah, this tends to be the wrong question to ask yourself. The better one would be like, what should be the capabilities that we should be designing through the platform, through open APIs that would foster composition into different services. So in her book, Zhamak conceptualizes a data platform in 3 planes based on capabilities and the users whose needs these capabilities serve. So the first plane is a data infrastructure plane. This is the most low-level plane that might actually coincide quite nicely with the low-level services coming from the operational world. So here, the services that are being offered are for compute, storage, identity, and other like fundamental capabilities of data engineering. The second plane that builds on top of the data infrastructure, or through the use of the APIs, rather, is called a data product plane. So this is all about managing the data product lifecycle, from creating a data product all the way to archiving or deleting a data product. And then the final plane is called the mesh experience plane, where we're dealing with the mesh as a whole, consisting of interconnected data products. So the services here could be about discovering a data product or monitoring the health of the mesh as a whole.
So when we are constructing our data platform, we have to think about who uses it, because we're trying to describe a methodology or an approach to platform creation that is user-centric and user journey-centric. So we have data product developers who are comfortable with data processing technologies. They have that expertise, and so maybe you can give them a bit more control and detail. We have data product consumers who are building data-driven services on top of our data products. Maybe they need a little bit more of a normal software engineering interface and one that relies less on specialist knowledge. We have data product owners who are responsible for delivering successful data products and prioritizing and guiding its evolution. We have data governance members that we've talked about in previous videos who need to implement and decide on policies. We have data platform developers, so people working in the self-serve data platform who might have a variety of skills around infrastructure that they need to construct that platform. And finally, we have data platform product owners, so product owners for the data platform itself who have to decide what kind of capabilities to offer, in what way, and in what order to build them in.
So, as Chris was mentioning, there are a lot of different users with different needs. And figuring out these needs and prioritizing these needs will be the first step in order for your organization to make the platform a success. So, at the beginning, it might even be better for the data platform developers to work really closely with the data product developers, maybe even in the same team, figuring out how to build the data product together and then abstracting away some services into a data platform. For example, like in your first data product, you might actually be working on some compute APIs and then building some sort of a data product creation experience on top of it. And yeah, all of this should be done in cooperation with the users at the beginning. Another thing to keep in mind is that at the beginning, it's best actually to keep things simple. So there is an example that comes from the team topologist book that Skelton and Pais use quite often, and it's about the fact that sometimes the organization actually has quite a lot of different platform services already existing. It's just nobody really knows what they are and how to use them. So a good wiki page showing what those different services are and how to use them might actually be good enough at the beginning. So then, once you have a platform, it's really important to start measuring the satisfaction of the users to know that the platform is actually bringing value and going in the right direction. And once you have done, and based on those measures, you should actually continue talking with your users and making sure that they're being consulted in the evolution of the platform.
So just to finish this video, we want to offer some extra advice from our experience. So not all the capabilities of a data platform have to be developed at once, but please focus on complete user journeys. So just like in a website or any other kind of user experience, if there's an interrupted or broken user journey, that can be really dislocating and frustrating for users. So you don't need every capability, but when you have some kind of interaction or job that people have to be done with the platform, please try to make that experience complete and smooth. Focus on the user experience. And just because platforms users are engineers doesn't mean they'll be productive working with low-level services. Don't treat them any lesser or worse because they're engineers. Don't use the fact that they have technical knowledge as a kind of lazy excuse to offer them more detail or configurability or obscure interfaces than is necessary. Like, treat them like they're customers. And finally, consider that planes optimize for different things and try to avoid blurring the capabilities together too much. So the data infrastructure plane should focus on optimizing for the machine for execution on probably a cloud environment. The data product plane is about optimizing developer experience for the data product lifecycle. And for the mesh experience plane, focus on optimizing the value for the mesh as a whole, because that's really an important part of the data mesh approach and why it's worth, taking this time to learn about how to do this as a coherent philosophy, because of the emergent value that's created by the whole data mesh working well together. Thanks very much.
Hi folks, welcome to the video on measuring success of the mesh. So, as you might imagine, by this point, a data mesh transformation journey is quite a long process. We've talked about how to create data products, how to start governance, how to build a platform, but how to know that you're actually on the right track and how to actually show to the management of the organization or to the leaders that we're quantifiably also on the right track. So for this, there is no one single metric. Instead, what we're doing is recommending a balanced scorecard with a number of metrics that could capture some of the data that should be the most important to you. And these metrics fall into these categories: agility, uptake, mesh effect, satisfaction, and engineering excellence. And we'll go through all of these categories in more detail now.
So when we introduced Data Mesh to you, we said that the whole point was to allow you to bring new data sources onto the mesh quickly and to allow new data use cases to be implemented more quickly. So one of the key things is to measure that that is in fact happening. So lead time to consuming the data products you have, lead time to producing a new data product that you haven't had before, maybe components of this. So depending on what stage you are in your journey, how long it takes to discover what data products are out there, are really good ways of making sure that you're delivering agility.
The second category is uptake. So it might be quite natural when you're at the beginning of the data mesh journey to start measuring what's the number of data products that the organization has created. And though it's not inherently wrong to do this, it's sometimes actually quite useful. There are certain dangers in it, right? Because it's not just the quantity of data products that's useful. It's actually whether there are use cases that are taking the advantage of these data products and how much these data products are actually being used.
So the mesh effect is also something you should consider measuring. So the point of data mesh is not just that individual data products have value, but that the whole should be greater than the sum of the parts. So measuring, for example, the quantity of data products used multiple times tells you something about reuse. The quantity of aggregations across domains tells you something about how the data mesh is helping you to join together different pieces of data your organization has that otherwise might not be able to be joined together.
Another category is satisfaction. And this is especially relevant for your platform services, but also for the data products themselves. So NPS, or the satisfaction score, is something that we see used quite often. The number of new things being done with the platform is a useful metrics. Then always talking to the end customers and figuring out what they're missing from the data products or the platform services is useful. And finally, how the data products are conforming to the SLOs or SLAs is also a useful metric.
Now, there's a lot of engineering involved in creating data products in a data mesh, so you should also think about measuring engineering excellence. So these four measures are not actually specific to data or data mesh at all. They're known as the DORA metrics, and they're used in different contexts to tell whether the engine of your engineering organization and your teams are performing well. So the lead time for changes, the deployment frequency, the mean time to restore when there's a problem, or the change fail percentage are also very useful in indicating whether you're doing well on the engineering front in your data mesh.
So one of the questions that we've gotten is one of the promises of data mesh is that it will lead your organization to have better data at scale. So why aren't we measuring anything related to data quality? And we're doing this because measuring data quality at scale tends to lead to an expectation issue. So it's not enough just to measure the data quality for the sake of it. You could find yourself in a situation where you're optimizing for higher data quality, but the data product is not actually being used and nobody's satisfied with it. So what's the point of optimizing for data quality? So doing that, regardless of what's the cost of effort, is a common fallacy that we see. Instead, one should be optimizing for usage and satisfaction.
Yes, and if you're optimizing for usage and satisfaction, then you're going to be giving the right amount of quality for the use cases that your users have in mind. Thanks very much. Hi everyone, welcome to our final video, Winning Hearts and Minds. So the sad truth is that in the IT industry, most digital transformations fail. The figure we dug up was 84%. And in many cases, that's because people think it's about just implementing tech, or they think it's enough to have an overall impressive strategy that lives in a PowerPoint deck somewhere, and they neglect the human element. Now, data mesh is a socio-technical approach that involves changing what responsibilities have for doing a good job. So it's very important that people have to change their behavior at a grassroots level for it to succeed. And if you want that to happen, if you want people to change what they're doing, you need to get them on board and understanding the value in the new way of work.
So one of the best ways to get people on board is to praise them for exhibiting the right behavior. So a leader's praise is one of the most effective change management tools. But also, don't people. If you're going to praise them for exhibiting the right behavior, make sure that the priorities and incentives are actually consistent. So an easy example, and maybe even a bit of a simplistic example, is that when you expect people to create data products, measure quality, monitor SLOs, and make products discoverable, make sure that the developers actually have enough time to do all of this. Don't expect them to just write some Spark code and move on to the next data product.
Yeah, nothing puts people off more than leadership hypocrisy. So one of the things you should also do is creating a space to talk. So some companies we've seen have got internal conferences about their data mesh adoption where people give talks or talk about resolving different issues that they might have in the implementation. Others have communities of practice that can be another route for knowledge sharing. Please don't forget the what does it mean for us conversation. Like data products and domains are abstract concepts and need work to localize. Don't skip that because it's really where a lot of the learning is going to happen.
So another thing to keep in mind is that teams need help on this journey. They don't just want extra responsibility, they want some support as well. So one of the patterns that we see working quite well is to create some sort of enablement or enabling teams within your organizations who can move from one domain to the next and help the teams within set up their first data products. And the same would actually work for platform and governance services as well. Don't just create them or set them up and hope that everything works out. You have to do a lot of marketing within the organization to kind of explain the value and the benefits and really show them. And sometimes it's as easy as setting up some knowledge sharing sessions. Sometimes you do need an enabling team to kind of bring this knowledge to the data products working.
And while you're helping them, it can actually be really good feedback as to whether what you're providing in governance and the data platform is actually working really well. So there are models of change management that you can use. This is one that we use in our work as consultants called the ADKAR model. It describes the different stages that you need to take into account if you're going to truly embed change, right? So people need to be aware of the intent to change. They have to be imbued with a desire to move towards the new state. They have to have knowledge of what the new state entails. They have to have the ability and skills to actually execute on that knowledge. And there has to be reinforcement to make sure that as they're going through this process, the new ways stick. So if you skimp on this process, maybe if you just announce we're doing data mesh and take no further action, you've really only hit the first of the 5 stages awareness. So we'd really recommend thinking about bringing along people on this full journey if you want to embed the new behaviors thoroughly.
And finally, we've talked quite a lot about like our experience on the data mesh journey, but there are a lot of other people on similar journeys in the data community. So one of the resources that we recommend is the Data Mesh Learning Slack channel. There are hundreds or even thousands of people on that Slack channel actively participating in furthering data mesh. There's also Data Mesh Radio. If you're more into podcasts, they bring use cases from actual companies on the data mesh journey. And then finally, we would really encourage you to participate in this community and share what has worked for you and what hasn't worked for you. So before we finish up, I'm really curious to hear how our friends at Nomad Nexus have actually done on this journey.
I can't divulge too many details, but I really think that if I was working on this transformation at Nomad Nexus, one of the things I'd be really keen on is to get people to share back the details of their achievements, the things that have worked really well, maybe the things that have worked less well. So the data products that our Nomad Nexus friends created to collate metrics on environmental impact and gentrification, that makes a really colorful story that I'm sure other people in the community would be grateful to hear. There is a virtuous cycle as well for sharing back, because when you share back your data mesh journey and the lessons you've learned along the way, it can really act to attract talent to your company. Right? Data mesh is a very popular and important theme at the moment, and there are really skilled engineers and product owners and platform people who really want to work on this kind of stuff, so that if you can be visible about your triumphs and your temporary setbacks, then you're going to have a great time of recruiting awesome people to work with you and to implement the best possible data mesh that you can, just like our friends at Nomad Nexus. So thank you all very much for attending our course and for making it this far. We really appreciate it, and we hope it's been really useful to you.